Beneath the surface of the ocean, beyond the reach of light and human touch, there exist secrets that have remained hidden for thousands of years. From impossible submerged structures to creatures never seen before, the ocean floor is Earth's last great mystery. Today, I invite you to close your eyes, take a deep breath, and dive with me into the unknown. The Sargasso Sea, the ocean that traps without reason. The Sargasso Sea is one of the strangest places on the planet. It has no shores and no clear physical boundaries, yet it stretches over more than 3 million square kilometers in the middle of the North Atlantic Ocean, east of the United States and north of the Caribbean. What makes this zone so special is that it is not a sea enclosed by land, but a sea within the sea, a region completely surrounded by ocean currents that act as invisible walls. The area takes its name from the floating algae known as sargassum, which grow in large quantities and spread across the surface of the water like a living carpet. These algae are not anchored to the seafloor. They float freely, yet they remain relatively contained by the rotating currents that enclose the area. The effect is that anything entering the Sargasso Sea, fish, debris, even abandoned ships, tends to become trapped. Since ancient times, sailors have remarked on the strangeness of the place. During his first voyage to the Americas, Christopher Columbus crossed this region and noted in his journals that the sea became thick, that sails lost strength, and that it seemed as if ships moved more slowly. The algae gave the impression that the ocean was covered by a heavy, dense layer. And although the plants themselves are not a serious physical obstacle, the sensation of sluggishness and entrapment persists in descriptions of this place even today. Curiously, despite its fame and unique characteristics, the Sargasso Sea has long been one of the least studied regions of the Atlantic Ocean. For a long time, it was overlooked by scientists, regarded merely as a transitional zone of little importance. However, recent research has revealed that it is an extraordinarily complex area, both ecologically and in terms of oceanic dynamics. What happens in the Sargasso Sea not only affects the North Atlantic, but also has consequences for global climate systems. One of the greatest mysteries is the behavior of the surrounding ocean currents. The Gulf Stream rises from the Caribbean, turns toward Europe, descends southward along the Canary Current, merges into the North Equatorial Current, and circles back to the starting point. This circulation creates a massive gyre that traps sargassum and other materials in the center, where the Sargasso Sea lies. Yet, why this rotation has remained stable over centuries, and even millennia, is still not fully understood. Another surprising fact is that the interior of the Sargasso Sea is anomalously calm. Despite being bordered by powerful currents, the inner waters are remarkably still, with little wind and sluggish movement. It is an area of nearly constant high atmospheric pressure, contributing to the sensation of a motionless sea. Many ancient sailing vessels feared becoming becalmed here. Stranded without wind, trapped among floating weeds, and exposed to the relentless sun for days or even weeks. Beyond its physical characteristics, the Sargasso Sea is home to several biological and natural mysteries. One of the most famous involves eels. Both the European eel and the American eel, two species separated by thousands of kilometers, are born in the Sargasso Sea. The larvae drift toward Europe or North America, grow in freshwater rivers, and then, years later, return to the same point in the ocean to reproduce and die. No one knows exactly how they navigate, nor how they recognize their birthplace. Most puzzling of all is that no one has ever witnessed adult eels spawning there. Only larvae have been found, suggesting that this hidden sea is their exclusive spawning ground. Yet the full process remains an unsolved mystery. The Sargasso Sea is also associated with numerous maritime disappearances. It lies near the region of the famous Bermuda Triangle, and although it is not directly part of the triangle, many shipwrecks, reports of ghost ships, and small craft vanishings have occurred within its bounds. Some theories suggest that the special conditions of the area, weak winds, circular currents, lack of visual landmarks, and altered magnetic fields, contribute to navigator disorientation. Others propose that the dense mats of sargassum may have interfered with early ship navigation systems. Even in modern times, strange phenomena continue to be reported. Pilots flying over the area have described erratic readings on their instruments, Ships have reported malfunctions in radar and electronic systems. Although many of these experiences can be explained by natural causes, electromagnetic interference, atmospheric stability, thermal differences, the accumulation of reports keeps the legend of the Sargasso Sea alive. Additionally, the region has become a massive collector of plastic waste and microplastics. The rotating currents trap not only algae and fish but also human-generated debris. This plastic soup has grown alarmingly over the decades, posing serious risks to the unique marine fauna that inhabits the sea. Many species become entangled or poisoned, and ecosystems that once thrived in isolation are now deteriorating at an alarming pace. And yet, the Sargasso Sea remains a vibrant oasis of life, home to species found nowhere else on Earth. From fish that camouflage themselves among the sargassum to microorganisms that live on its floating surfaces, the region acts as a suspended liquid continent in the middle of the Atlantic Ocean, without land, yet sustaining entire ecosystems on its drifting gardens. Today, the Sargasso Sea remains largely unexplored and poorly understood. Its boundaries are fluid, its currents shift subtly with the climate, and its impact on ocean circulation and global climate balance is greater than once believed. It is a sea without shores, a spiral of life, silence, and riddles. And although there are no towering waves, no mountains, no raging storms, what makes it unsettling is its persistent calm, its passive appearance, as if it hides something more beneath its tranquil surface. The Bloop Sound, the terrifying roar from the abyss. In the summer of the year 1997, a team of scientists monitoring ocean sounds for seismic activity captured something they were not looking for. It was a deep noise, extremely powerful, with a very low frequency that traveled thousands of kilometers underwater. A sound so strong that it was recorded simultaneously by underwater microphones separated by more than 5,000 kilometers. They called it Bloop, and since then, it has remained one of the most puzzling and debated sounds of the modern oceans. What makes this phenomenon so unusual is not just its strength, but its completely unknown nature. The oceans are full of sounds: underwater earthquakes, volcanic activity, the cracking of ice, the singing of whales, the rumble of deep currents. However, Bloop did not resemble any of those sounds exactly. It was organic in pattern but too powerful to be produced by any known creature. It also did not match typical geological noises, and for years the source of the sound remained unexplained. The recording of Bloop was made by the National Oceanic and Atmospheric Administration of the United States, which had deployed a network of long-range hydrophones originally designed to track submarines during the Cold War. These instruments are capable of detecting very low-frequency sounds in the deep ocean, even when they occur thousands of kilometers away. The sound was detected mainly by hydrophones in the South Pacific Ocean, west of South America, near Antarctica. Its frequency was so low that it was below the threshold of human hearing, but when it was accelerated and processed, it became recognizable. A rising burst, like a roar or a growing bellow. Hence the colloquial name it has been known by ever since, Bloop. Immediately after its discovery, speculation began. Some scientists noted that the frequency pattern of the sound was similar to that of a living creature, something that appeared to have a muscular cycle and organic form of emission. But what was bewildering was the scale. No known animal, not even the blue whale, the largest creature ever to have lived on Earth, could produce a sound of that magnitude. To emit a noise of such intensity underwater, the organism would have to be many times larger. Were we witnessing evidence of a marine creature yet to be discovered? The hypothesis of a colossal unknown being quickly gained attention beyond the scientific community. Writers, enthusiasts of the paranormal, and followers of marine myths began linking Bloop to ancient legends. Abyssal monsters, prehistoric creatures surviving in the deep, even to Cthulhu, the fictional entity invented by Howard Phillips Lovecraft, whose supposed resting place, Relia, roughly coincides with the location of the sound. Although this interpretation was more literary than scientific, the truth was that no convincing explanation existed for years. Human sources were ruled out, as there was no recorded industrial activity in the area at the time. Volcanic explosions were also discarded, as there were no nearby eruptions or seismic events matching the nature of the sound. As more data accumulated, new and more conservative theories emerged. Some researchers proposed that bloop might have been caused by large ice fractures, especially in the Antarctic glaciers. These mass breakages of ice generate a type of sound wave that, under certain conditions, can resemble bloop. The idea that it was an icequake, a glacial earthquake, began to gain technical support, especially since other similar sounds, such as slow down or Julia, also recorded in the South Pacific, seemed to share characteristics with the movement of ice masses. In the year 2012, the National Oceanic and Atmospheric Administration officially leaned toward this theory. They declared that bloop was most likely caused by the cracking of a massive block of ice, possibly a glacier collapsing into the sea. This would explain both its intensity and frequency. However, many experts point out that this explanation is not entirely conclusive. Although icequakes generate powerful sounds, not all elements of bloop match that acoustic signature. Some components of the sound, such as its rising structure, remain difficult to explain solely through ice fracturing. And there is another problem. Bloop was unique. Since its detection in the year 1997, no sound exactly like it has ever been recorded again. Other similar noises have been catalogued, but none with the same intensity, behavior, or precise location. This keeps open the possibility that, whatever the cause was, it was something exceptional, possibly unrepeatable or still unknown. Moreover, the South Pacific Ocean near Antarctica is one of the most unexplored regions of the planet. Harsh climate conditions, logistical challenges, and the vastness of the ocean make this area among the least studied in the world. The abyssal depths reach several thousands of meters, and what lives there still escapes scientific understanding. In fact, in recent years, completely new species have been discovered in these regions, including fish, mollusks, and invertebrates with such radical adaptations that they seem from another world. Creatures that glow in the dark, endure extreme pressures, and feed on chemical compounds rising from Earth's interior. If entire ecosystems can exist hidden kilometers beneath the sea, why could something even larger not be awaiting discovery? Another interesting theory is that bloop could result from an unknown acoustic phenomenon, such as the collision of water masses with different temperatures or densities, creating a large-scale cavitation effect. Such events could produce brief, powerful, and difficult-to-track sounds. However, the absence of a repeatable pattern complicates this explanation. Today, bloop remains an open case. The glacial cracking explanation is technically the most accepted, but it is not definitive. The recordings of the sound are publicly available and have been analyzed over and over again. Every year, new studies attempt to offer more precise answers. Yet the mystery persists, fueled by the silence of the deep and the impossibility of directly observing what happens several kilometers below sea level. What began as a simple acoustic anomaly detected by chance has transformed into one of the most famous modern enigmas of the ocean floor. Not because of the amount of data, but precisely because of its scarcity. Because sometimes, a single sound is enough to remind us how little we truly know about the planet we inhabit. And so, bloop continues to resonate, not only in the digital archives of the National Oceanic and Atmospheric Administration, but also in the imagination of those who, standing before the sea, wonder what truly dwells in the darkness we can never see. The Great Blue Hole of Belize, a bottomless pit echoing prehistoric times. In the middle of the Caribbean Sea, off the coast of Belize, there opens an immense, perfectly circular cavity. Its blue darker than the rest of the ocean. Its outline seems drawn with a compass, and its depth is lost in the shadows of the waters. This is the Great Blue Hole, one of the most impressive and enigmatic underwater structures on the planet. At first glance, it appears to be a simple geological formation, a whim of nature. But upon deeper investigation, questions arise that even today remain unanswered. This gigantic marine sinkhole measures more than 300 meters in diameter and 125 meters in depth, making it one of the largest and deepest blue holes in the world. It is located at the center of the Lighthouse Reef Atoll, approximately 70 kilometers from the coast of Belize, and it forms part of the Mesoamerican Barrier Reef, the second largest coral barrier on Earth after the Great Barrier Reef of Australia. However, what truly fascinates scientists about the Great Blue Hole is not merely its size, but its geological origin. For years, scientists believed it was a submarine doline formed by erosion of the ocean floor. However, later studies demonstrated that this cavern was actually formed on dry land during the last ice age, when sea levels were between 100 and 120 meters lower than they are today. At that time, the area where the hole is now located was part of a system of limestone caves developed by the filtration of fresh water, similar to many terrestrial caverns. The stalactites found inside, formations that can only be produced out of water, confirm that the hole was once a dry cave for thousands of years. But at the end of the glaciation, the oceans began to rise, flooding the caves and causing their collapse. The roof gave way, and the cavern became a giant sinkhole, hidden by the waters of the Caribbean. This geological process is not rare in itself. What is strange is the geometric perfection of the hole, its isolated location, and its layered structure. The cave did not collapse chaotically. Its walls are smooth and vertical, and inside there are chambers and levels as if they had been carved. This design has led some researchers to think that the cavern might not have been purely a natural phenomenon, but possibly a place used or adapted by ancient cultures. Although there is no direct evidence of prehistoric human presence inside the hole, the region was inhabited by the Maya civilization for centuries. Some archaeologists believe that the hole may have held ritual or spiritual significance. In the Mayan worldview, cenotes, natural freshwater sinkholes, were considered portals to the underworld. If a similar symbolism applied to marine structures, it would not be unreasonable to think that the Great Blue Hole was regarded with awe by ancient civilizations. In the 20th century, the hole began to gain international fame, thanks in part to the work of the French explorer and filmmaker Jacques-Yves Cousteau, who visited the site in the year 1971 aboard the ship Calypso. Cousteau declared it one of the best diving sites in the world and helped spread its image through documentaries and publications. However, even Cousteau noted that there was something unsettling within its depths. A profound silence, an almost immediate vertical descent, and a sense of immensity enclosed within. Divers who have ventured into its depths describe a changing environment. The first 30 meters are crystal clear, inhabited by corals, tropical fish, nurse sharks, and reef sharks. But as one descends further, the water becomes darker, colder, and denser. Below 90 meters, a layer of hydrogen sulfide forms, literally separating the water into two worlds. Above, the known marine life. Below, an anoxic environment where nothing survives. This toxic gas layer results from the decomposition of organic matter accumulated over centuries at the bottom. Curiously, after passing through that barrier, the landscape changes completely. Divers enter a silent void, without fish, without light, without movement. The walls are covered with gigantic stalactites, formed when the cave was still dry. Some measure more than 9 meters in length and hang intact, as if time had been frozen in that space. In a recent expedition led by the foundation of Richard Branson, a special submarine was used to explore the bottom of the hole. What was found was disturbing. The floor was covered by a dense layer of fine sediment, within which human and animal remains were found trapped, along with pieces of lost diving equipment. One of the surprises was the discovery of a completely oxygen-free chamber sealed by water pressure, a space that has possibly remained unchanged for thousands of years. This discovery has sparked new speculation. If that place has been sealed for so long, what else could be hidden there? Is it possible that unknown forms of life exist, preserved in that oxygen-free environment? Or even archaeological remains that have not been altered since prehistoric times? The Great Blue Hole is not merely a tourist attraction. It is a natural laboratory, a time capsule, an open crack into the Earth's past. The way it formed, the manner in which it has been preserved, and the extreme conditions it presents make it an ideal place to study both geological history and the limits of life in extreme environments. It also raises questions about the fragility of the marine environment. On the surface, the coral barrier that surrounds it has begun to suffer damage from climate change, pollution, and human activity. Water temperatures have risen, and the corals are showing signs of bleaching. This means that the hole, for all its appearance of eternity, is also subject to change and could alter over time if not properly protected. At its core, This perfect sinkhole is a reminder that beneath the surface of the sea, there is much more than water and sand. There are structures that hold stories from times when the world was completely different. Stories carved in stone, covered by layers of toxic gas, wrapped in the absolute silence of the depths. The great blue hole of Belize remains there, with its circular shape, its dark abyss, and its mystery intact. A place not created by human hands, yet containing all the conditions needed to make us feel as if we are standing before an open door to the unknown. The Baltic Anomaly, natural formation or ancient craft. In the summer of the year 2011, a team of Swedish explorers specializing in shipwreck recovery made a discovery that would soon become one of the most discussed mysteries of the seafloor. Aboard the ship Ocean Explorer, and using side-scan sonar, they detected a strange formation on the bottom of the Baltic Sea, between Sweden and Finland. What initially seemed like just another geological accident quickly captured their attention due to its unusually symmetrical shape and the strange readings that accompanied the image. The team named it the Baltic Anomaly. The sonar image showed an object approximately 70 meters in diameter, with a shape many described as a flying saucer or a giant mushroom. The top was almost perfectly circular, with sharply defined edges, and it appeared to be connected to a sort of landing track or rectilinear trail extending more than 300 meters down the seabed. For the Ocean X team, it was not merely a rocky outcrop. It was something that appeared designed, or at least molded in a way that defied common geological explanations. The initial photographs triggered a wave of speculation. Some believed it could be an ancient artificial structure, perhaps the remains of a lost civilization. Others compared it to the Millennium Falcon from Star Wars, due to its rounded outline and mechanical appearance. Social networks filled with theories. An extraterrestrial ship? A sunken Nazi bunker? An entrance to an underwater base? A forgotten technological relic? Initially, the lack of high-quality images fueled the mystery. The team had captured the images with limited-resolution sonar and could not immediately descend to the site due to the challenging conditions of the Baltic Sea. Low visibility, cold temperatures, and an irregular seabed. Moreover, the team lacked the financial support required for a full-scale scientific expedition, leading to doubts about the interpretation of the discovery. However, during a second expedition, Ocean X managed to send divers to the location. What they found was a rocky structure with angular shapes and regular grooves. Some sections were completely smooth, while others appeared melted or affected by high temperatures. Intense electromagnetic interference was also detected in the area, which disrupted electronic equipment. Cameras, lights, and even telephones ceased functioning when approaching the object. This technical anomaly was interpreted as further evidence that the object possessed something beyond geological interest. From the samples recovered, the divers brought back fragments of rock that were later analyzed in laboratories. Reports indicated that they consisted of common minerals: granite, gneiss, and other igneous rocks. This reinforced the idea that it could indeed be a natural formation, shaped by the action of ice during the glaciations of the Pleistocene epoch. The Baltic Sea, after all, was a highly active region during that period. Drumlin-type formations, created by the movement of glaciers, can take on unusual shapes, even displaying superficial symmetry. But the mystery did not end there. One aspect that most caught the attention of researchers was that the structure seemed to protrude from the seabed, as if it were partially embedded, rather than formed entirely of the same material as the surrounding seafloor. There were also parallel grooves across its surface, which did not match natural fractures, and areas where the seabed appeared to have been pushed or displaced. Additionally, in the surrounding area, what seemed to be burned or vitrified remains were found, as if part of the object had been exposed to extremely high temperatures. This type of evidence is unusual in common geological formations and has been used as an argument by those who believe that the anomaly has an artificial origin or has been subjected to extreme events. Another important observation was the detection of what appeared to be a kind of staircase or descending ramp connected to the top of the object. Although this detail can be interpreted in many ways, its symmetry is striking. Some geologists argue that it is simply a visual effect produced by differential erosion. Others believe it could be a platform carved or modified. The more conservative scientific analyses, especially from Scandinavian universities, have argued that the anomaly is merely an example of unusual glacial morphology. According to this perspective, the movements of the glaciers that covered the region more than 10,000 years ago left behind erratic blocks and mounds that, over time, were eroded by marine currents, sediments, and temperature changes. In this process, symmetries and uncommon textures could have formed without necessarily being artificial. However, proponents of alternative theories argue that there are too many coincidences for everything to be attributed to geological randomness. They point to the shape, the radial pattern, the right angles, the electromagnetic effects, and even the alignment of the object relative to magnetic north. They also mention that the area has historically been rich in legends about strange lights over the sea, disappearances, and objects falling from the sky. Although there is no solid evidence linking these stories to the anomaly, the cultural context continues to fuel the mystery. Despite the international interest it has aroused, the Baltic Anomaly has not been studied with the depth it deserves. There are no large-scale independent scientific investigations, and private exploration teams have faced logistical and financial limitations. Furthermore, the lack of collaboration between explorers and universities has led to a division between those seeking answers through conventional science and those who remain open to non-traditional possibilities. Today, the object remains there, more than 90 meters deep, in dark and icy waters. It has been photographed, measured, mapped, but not definitively explained. And each time someone attempts to classify it as merely a natural formation, new details emerge that reignite the doubt. Is it a strange stone sculpture formed by ice and time? An ancient structure built by human hands, lost since prehistory? An artifact fallen from the sky, covered by sediments for centuries? Or simply a visual illusion created by our minds when faced with something we do not fully understand? The Baltic Anomaly remains an enigma, silent, submerged, and beyond the reach of the human eye. It waits in the gloom of the seabed. Perhaps, over time, its true nature will be revealed. Or perhaps not. Some mysteries, after all, seem to prefer sleeping beneath the waves. The submerged pyramids of Yonaguni, a lost city beneath the waves. In the far southwest of Japan, near Yonaguni Island, lies one of the most controversial underwater structures ever discovered. It was not found by archaeologists or geologists, but by a local diving instructor in the year 1986 while exploring the reefs in search of new sites for recreational diving. What he found did not fit the natural landscape of the ocean. Enormous stone blocks, carved steps, flat surfaces, and right angles that, at first glance, appeared to have been designed by human hands. Since then, the so-called Yonaguni monument has sparked intense debate between those who consider it an unusual geological formation and those who maintain that it is the remains of an ancient sunken civilization. The main structure lies about 25 meters underwater and measures approximately 150 meters in length by 40 meters in width, with a height of more than 25 meters. Its profile resembles a stepped pyramid or a kind of ziggurat, with descending terraces, lateral platforms, ramps, and even what seemed to be perfectly aligned staircases. The site was studied by Professor Masaaki Kimura, a marine geologist from the University of the Ryukyus, who led expeditions to the location for more than 15 years. Kimura argues that the monument is clearly artificial, or at least modified by human activity. According to his observations, there are rectilinear walls, drainage channels, carved symbols, and even what could have been a central plaza. For him, Yonaguni represents the remains of a city built by a vanished civilization more than 10,000 years ago, when sea levels were significantly lower. Kimura's main argument is the geometric symmetry of the structure. The cuts in the rock are straight, the corners form angles close to 90 degrees, and some zones appear to have astronomical orientation. There are narrow passageways, horizontally aligned ledges, and patterns that are rarely found in natural formations. Furthermore, near the main monument, other smaller submerged formations have been found, which could have been towers, roads, or altars. The presence of possible symbolic carvings on the rocks has also been documented, although many are eroded and their interpretation remains uncertain. Kimura and his team claim there are petroglyphs resembling characters from the earliest Japanese writing systems, primitive forms of kanji, suggesting an organized society with written language. Additionally, some blocks appear to have been separated from the bedrock by horizontal cuts, implying the use of tools, extraction techniques, and deliberate planning. However, these assertions have not been accepted by most of the scientific community. Traditional archaeologists and skeptical geologists maintain that the structure can be explained through known geological processes, especially in a tectonically active region like Japan. The type of rock that composes the monument, sandstone and mudstone, tends to fracture along horizontal and vertical planes due to the combined action of plate movement, marine erosion, and weathering. This can produce surprisingly rectangular shapes without human intervention. It is also argued that the steps and platforms could result from differential erosion, where harder rock layers remain while softer ones wear away. In this view, the Yonaguni structure would be a geological curiosity, but not a sunken city. For these experts, there is no conclusive evidence of human activity. No tools, no ceramics, no skeletons, nor internal structures such as rooms or collapsed roofs. Nevertheless, proponents of the artificial hypothesis respond that the lack of artifacts does not invalidate the possibility of construction, since thousands of years under the sea could have erased most movable elements. Moreover, if the civilization that built the monument was destroyed by a cataclysm, such as a massive flood or earthquake, it is possible that their remains were washed away or scattered. It is also likely that the site has not yet been properly excavated, due to the technical difficulties of working at such depth, and that evidence remains buried beneath layers of sediment. One of the most intriguing aspects is the estimated age of the structure. If it was indeed constructed by humans, it must date back to a time before the last significant sea level rise, meaning at least 10,000 years ago. This would place its origin earlier than known civilizations, even before the cities of Mesopotamia or Egypt. In such a case, we would be speaking of a lost culture completely unknown to official history. Some researchers have linked Yonaguni to the mythical civilization of Mu, an Asian version of the Atlantis myth, which according to certain legends existed in the Pacific before sinking for unknown reasons. Although these theories lack concrete archaeological evidence, their existence demonstrates the symbolic impact of Yonaguni as a gateway to forgotten antiquity. Beyond disputes over its origin, what no one disputes is that the Yonaguni monument is a unique site in the underwater world. Its size, shape, and visual impact make it an enigma that continues to attract divers, researchers, and curious visitors from all over the world. Even in low visibility conditions, those who descend to it describe a strange sensation: the feeling of standing before a submerged ruin, as if history itself had frozen beneath the water. Over the years, there have been attempts to create three-dimensional models of the site, topographic maps, and virtual simulations. But so far, no definitive consensus has been reached. For some, Yonaguni is a marvel of nature, a perfect example of how time and water can carve stone with deceptive precision. For others, it is a buried clue to a civilization that predates memory, whose secrets remain hidden in the ocean's depths. What is certain is that the Yonaguni monument continues to challenge our ideas about the past. Whether natural or artificial, it represents a blurred line between what we know and what we believe we know. And as long as the water continues to cover its shapes, that boundary will remain uncertain. The Challenger Deep, the deepest and most unknown point on the planet. The planet Earth is covered by more than 70% water, yet much of that vast ocean remains an almost unexplored territory. Within that submerged realm exists a place that represents the deepest point on the planet, a fissure in the Earth's crust that plunges into darkness as if it had no end. This place is called the Challenger Deep, and it lies within the Mariana Trench in the western Pacific Ocean. The estimated depth of the Challenger Deep is approximately 10,984 meters, although measurements vary slightly depending on the technology used and the conditions at the time. To put this in perspective, if Mount Everest were placed inside the trench, its summit would remain submerged under more than 2 kilometers of water. We are speaking of the point furthest from the Earth's surface anywhere on the planet, an environment so hostile and unknown that it continues to pose enormous challenges to modern science. The trench was discovered in the year 1875 by the British expedition aboard HMS Challenger, which gave the depression its name. During their voyage, The scientists on board used a system of cable-sounding devices to measure the depth of the ocean. What they found near the Mariana Islands surpassed anything known until then. However, more than a century had to pass before human beings could physically approach that place. In the year 1960, a historic achievement marked a before and after in underwater exploration. The bathyscaphe Trieste, designed by Auguste Piccard and piloted by his son Jacques Piccard alongside United States Navy Lieutenant Don Walsh, descended to the bottom of the Challenger Deep, remaining there for about 20 minutes. It was a solitary mission without high-definition cameras, robotic arms, or sophisticated sample collection systems. Through a small viewport, the crew could barely observe a muddy seafloor and the presence of some organisms. The most surprising observation was the apparent existence of life at such extreme depths, defying the idea that such drastic conditions were incompatible with biology. Since then, there have been very few missions that have reached the bottom of the trench. The pressure at that depth exceeds 1,100 atmospheres, equivalent to more than 8 tons per square centimeter. For a vessel to withstand that without collapsing, it must have an extremely resistant and compact design. The temperature is close to freezing, the darkness is absolute, and communications are difficult due to the density of the water. In the year 2012, filmmaker and explorer James Cameron conducted a new solo descent to the bottom aboard his submersible deep-sea Challenger. It was the first solo journey to that depth and allowed for the collection of samples, high-resolution photographs, and unprecedented footage. The seafloor turned out to be a desolate landscape, with fine sediments, strange formations, and life forms adapted to extreme conditions. Among the most surprising findings of modern expeditions are extremophile microorganisms capable of surviving without light, without free oxygen, and in an environment with pressure that would crush any conventional life form. These organisms obtain energy through chemical processes such as chemosynthesis, feeding on compounds like methane or sulfur. These discoveries have fueled research in astrobiology and the exploration of oceanic moons such as Europa or Enceladus in the solar system. Furthermore, studies of the trench have revealed the existence of fish, crustaceans, and jellyfish adapted to total darkness, some completely translucent, others bioluminescent, with gelatinous bodies and lacking rigid skeletal structures. These creatures not only endure the extreme pressure, but also form entire ecosystems depending on the organic matter falling from higher ocean layers, in a slow process known as marine snow. Despite these advances, most of the Challenger Deep remains a mystery. The surface of the planet Mars has been mapped in greater detail than the bottom of this oceanic abyss. The available images are scarce, taken by unmanned vehicles that have barely touched parts of the trench floor. Researchers estimate that more than 80% of the global ocean remains unexplored directly, and the Challenger Deep represents one of the most complex challenges within that vast unknown. There are also geological factors that make this place even more fascinating. The trench is located at a point where the Pacific Plate sinks beneath the Philippine Plate, a process known as subduction. This tectonic activity not only generates the depression in the Earth's crust, but also deep earthquakes and the possible emergence of heat sources from the Earth's mantle. This suggests that, in certain areas of the trench, there might be undiscovered hydrothermal vents, similar to those found in other deep-sea regions. These vents emit mineral-rich compounds and heat, potentially supporting even more complex life forms. The problem is that accessing these zones requires expensive technology, meticulous planning, and missions extremely limited by time, autonomy, and weather conditions. Beyond its scientific aspects, the Challenger Deep has also inspired numerous theories, some more speculative than others. There are those who propose it could serve as a refuge for prehistoric marine species that survived mass extinctions. Others suggest it could harbor underwater caves or ecosystems isolated for millions of years. Although these ideas lack direct evidence, the true lack of knowledge about the trench leaves room for many possibilities. In certain circles of conspiracy theories and science fiction literature, it has even been imagined that the trench hides secret facilities, sunken vessels, or entrances to tunnels leading to the Earth's interior. Although these ideas are not scientifically supported, they reflect the symbolic power of such an inaccessible and mysterious place. It represents the extreme limit of what we do not see, what we do not understand, what has yet to be revealed. From an environmental perspective, the Challenger Deep has also begun to show troubling signs. Traces of human pollution have been found at depths greater than 10,000 meters, including fragments of plastic, toxic particles, and pesticide residues. This demonstrates that even the most remote places on the planet are not exempt from human impact. It serves as a reminder that our footprint has reached the deepest corners of the world, often before we ourselves arrive to explore them. In summary, the Challenger Deep is not merely a trench in the ocean. It is a living frontier between what is known and what remains hidden, a testimony to life's capacity to adapt to impossible conditions, and at the same time, a mirror of our ignorance. As long as we remain unable to fully explore it, it will continue to be one of the great mysteries of the deep sea, a real abyss that, until now, has offered more questions than answers. The phantom island of Bermeja, a piece of land that disappeared from the map. In the Gulf of Mexico, hundreds of kilometers northwest of the Yucatan Peninsula, there should exist an island. At least, that is what ancient maps, nautical treaties, and official records of the Mexican government affirmed for centuries. That island is called Bermeja, and according to cartographic charts from the 16th to the 20th centuries, it was a small piece of land located in the open sea, strategically important for its position, and seemingly vanished without a trace. Today, Bermeja Island is one of the most intriguing geopolitical and cartographic mysteries of the modern ocean floor. The existence of Bermeja was first documented in the year 1539, in a map created by Alonso de Santa Cruz, cartographer of the Spanish crown. At that time, sea voyages were slow, dangerous, and dependent on imprecise maps, so any piece of land that could serve as a reference point was considered valuable. Over the centuries, the island continued to appear in numerous nautical charts, including official documents from the Spanish Navy, British explorers, and even scientific records from the 19th century. In all these representations, Bermeja was described as a low-lying island, reddish in color, hence its name, surrounded by deep waters, about 100 kilometers north of the Mexican state of Yucatan. For decades, no one questioned its existence. Although it was neither a tourist destination nor an inhabited site, Bermeja repeatedly appeared in records, both military and commercial. However, interest in this small island grew significantly at the end of the 20th century, when diplomatic discussions between Mexico and the United States began regarding the delimitation of the continental shelf in the Gulf of Mexico, a region rich in oil and strategic resources. According to international law, a country can extend its exclusive economic zone beyond 200 nautical miles if it possesses islands or emerged territories that support such extension. In this context, the presence of Bermeja would have allowed Mexico to claim a much larger portion of the Gulf, known as the Donut Hole, rich in hydrocarbons and of great geopolitical value. But when an attempt was made to locate it precisely to support this claim, the island was not there. In the year 1997, the Mexican government organized an official expedition to verify its location. Nautical charts, historical coordinates, and modern satellite location technology were used. However, after surveying the entire indicated area, no physical trace of the island was found. There were no rocky formations, no beaches, no sandbanks, only open sea. Years later, in 2009, the National Institute of Statistics and Geography, INEGI, and the Mexican Navy repeated the search, using sonar equipment, multi-beam scanning systems, and bathymetric studies of the seafloor. The result was the same. There was no submarine elevation indicating that there had ever been solid ground at that point. Bermeja Island, it seems, had vanished from the map. This fact sparked a wide range of theories, both technical and conspiratorial. Some experts suggested that Bermeja never actually existed, and that its presence on the maps was the result of navigational errors, confusion with floating algae banks, or simple misinterpretations of temporary formations such as atolls or sandbanks moved by marine currents. In the era before satellite positioning systems, such errors were common, and many registered islands eventually turned out to be mirages, low clouds, or natural floating structures. However, other researchers believe that the island did exist but was destroyed by natural causes. One hypothesis suggests that Bermeja was a coral or sandy island, formed by sediment accumulation on an unstable underwater platform. Such formations, known as cays, are highly vulnerable to tropical storms erosion, and even changes in sea level. If this were the case, a particularly strong hurricane or a series of storms could have eroded it completely, submerging it forever. There is also the proposal that Bermeja might have been swallowed by a tectonic subsidence. Although the Gulf of Mexico is not a highly seismic zone, there are active geological faults in the region. A minor tectonic event, combined with the unstable nature of the seabed, could have caused a sudden collapse or sinking. In fact, some bathymetric scans have detected circular depressions on the seafloor near the area where Bermeja was supposed to be, suggesting possible seabed collapses. But the most controversial theory is the one that claims the island was deliberately destroyed. For years, various groups have suggested that Bermeja was eliminated due to strategic interests, particularly regarding its impact on the delimitation of oil-rich zones. According to this hypothesis, during the negotiations of the Gulf of Mexico Boundary Treaty between Mexico and the United States in the early 2000s, the existence of Bermeja would have been an obstacle to agreements favorable to foreign companies. Consequently, it has been proposed that the island was dynamited or artificially eroded using military or advanced marine engineering technology. Although there is no official evidence supporting this theory, the fact that the island disappeared precisely when its presence would have altered key international treaties has kept suspicion alive. Adding to this are reports that the initial mentions of its disappearance were handled discreetly, and that the Mexican government delayed providing clear explanations to the public. Some journalists and independent researchers claim there are classified documents about Bermeja that have not been released, and that they could contain details about its study, monitoring, or possible destruction. The story of Bermeja has also been compared to that of other phantom islands recorded in different parts of the world. For example, Sandy Island, a supposed island in the Pacific that appeared on maps until the year 2012 and was later removed after being proven non-existent. These cases show that even in the modern era, cartographic errors can persist for centuries, and that the sea still holds poorly documented or shifting zones. Today, the mystery of Bermeja Island remains unsolved. Official expeditions have made it clear that there is no solid land at the historical coordinates. Yet there is no absolute consensus on whether the island was a mistake from the beginning, a geological accident, or a victim of political and economic interests. The only certain fact is that an island, recorded for nearly 500 years, disappeared without leaving a physical trace, precisely when its existence could have changed the economic destiny of an entire region. Whether it is a cartographic myth, an overlooked natural disaster, or a covert action, the story of Bermeja reminds us that even today, in the digital age, maps do not always tell the whole truth. The hexagonal structure of the Gulf of Mexico, a pattern on the seafloor that should not exist. In the natural world, perfect geometry is rarely common. Although repetitive patterns do exist in nature, such as the spirals of a seashell or the hexagonal shape of a honeycomb, their appearance in large-scale geological underwater structures is extremely rare. That is why, when a formation of almost perfect hexagonal figures was detected on the seafloor of the Gulf of Mexico, the scientific community found itself facing a phenomenon that did not fully fit into known geological models. This discovery was made thanks to images captured by high-resolution bathymetric scanners, technologies used to meticulously map the topography of the ocean floor. These scans are usually conducted by petroleum companies, scientific institutions, or governmental agencies investigating the seabed in search of resources or geological risks. It was during one of these campaigns, in the mid-2010s, that formations with a well-defined hexagonal pattern began to appear in the records, stretching across several square kilometers of the Gulf seafloor. The information was not widely disseminated at first. The first to speak openly about the matter were members of academic teams who had access to public databases from the United States Geological Survey and the National Institute of Statistics and Geography of Mexico. According to the reports, the hexagonal structures were not only precisely aligned but also seemed to have almost identical dimensions to one another, as if they had been drawn with a gigantic ruler on the ocean floor. Such symmetry is unusual even in volcanic or sedimentary formations, which tend to show more irregular shapes due to the dynamic forces acting upon them over thousands or millions of years. What was most baffling was the mathematical regularity of the pattern. Each figure displayed 6 sides with angles close to 120 degrees, and the joints between one hexagon and another were so precise that they resembled a massive mesh. One initial theory proposed that these figures might be the result of thermal contraction processes, similar to those that generate basalt columns on land surfaces, as seen in the famous Giant's Causeway in Northern Ireland. In such cases, lava cools and contracts, forming fractures in polygonal patterns, usually hexagonal. However, this phenomenon occurs in exposed volcanic rock, not at great depths underwater, nor in sedimentary contexts such as those predominant in the Gulf of Mexico. Another suggestion was that the pattern could be due to processes of compaction and fracturing of marine clays under specific conditions of pressure, temperature, and time. Although some simulations have shown that fine sediments can develop polygonal patterns under extreme conditions, no experiment has been able to replicate a case with the dimensions and regularity observed in this area of the Gulf. The fact that the region where these figures were detected is also an area of intense petroleum exploration heightened curiosity. Some researchers speculated that the structures could result from some type of forgotten or classified human operation, such as geotechnical tests, systematic drilling, or even structures deliberately submerged for unknown reasons. However, the petroleum companies themselves denied having carried out any works that could produce those patterns, and no technical record exists of an industrial operation that would explain such a design. Another element that puzzled analysts was the depth and isolation of the pattern. The hexagonal structures are located more than 1,000 meters deep, in an area that does not exhibit recent volcanic activity, intense tectonics, or known hydrothermal processes. There is also no evidence of strong currents that could have shaped the sediments into such a form. This rules out several traditional explanations. In the year 2018, an international team of geophysicists attempted to mathematically model the pattern to determine whether it could be the product of an internal geological collapse, such as a methane gas bubble released from the subsurface, which, upon expansion, could have created radial pressure on the sediments. In that scenario, the hexagonal pattern would be a collateral effect of pressure release fractures. However, the results failed to reproduce the geometric regularity observed in the real images. The model generated polygonal shapes, but of varying sizes and without the nearly perfect distribution seen in the actual site. Thus, more speculative theories arose. One proposes that the hexagonal formation could be a vestige of ancient human constructions, submerged after the sea level rise thousands of years ago. This idea is based on the possibility that parts of the Gulf of Mexico, now underwater, were once exposed during glacial periods, and that a primitive coastal civilization might have left traces in stone or structures that were later covered by marine sediments. Although no direct evidence of human presence has been found in the area, no artifacts, no remains of vertical constructions, the theory persists among some circles of alternative research, who argue that the symmetry of the pattern is too precise to be the result of natural processes. Some have even suggested that the pattern could be part of an ancient underwater infrastructure, such as canals, platforms, or foundations, now eroded. Another hypothesis points to non-human forms of intelligence, whether biological or artificial, that could have influenced the formation or arrangement of the pattern. While these ideas are considered marginal in the scientific community, they reflect the fascination sparked by any underwater structure that challenges conventional geological explanations. The truth is that there is no consensus on the origin of the hexagonal structures in the Gulf of Mexico. It is not an optical illusion or a technical anomaly in the scans, as they have been detected by different teams using different technologies. They are there, drawn on the seafloor without a clear explanation, without direct geological context, and without documented precedents on that scale. The mystery persists also because no direct underwater exploration has been carried out in the area. For various reasons, depth, budget, logistical complexity, no mission with remotely operated vehicles has descended to closely examine the structure. All that is known comes from remote scans and digital topographic models. Until a detailed visual investigation is conducted, the mystery will remain open. The hexagonal pattern on the Gulf seafloor not only raises questions about extreme geological processes, but also forces us to reconsider the limits of our knowledge about underwater landscapes. In an environment we have only just begun to map with precision, how many other structures like this could be hidden in the depths? The ocean floor continues to reveal details that contradict our assumptions. This geometric pattern, drawn with a precision that would seem unreachable underwater, is a clear example of how much we still have to discover. And until someone descends, observes it up close, and studies it with the right tools, it will remain an enigma. A network of hexagons that should not be there, but is. The mysteriously severed submarine cables, silence in the age of connection. In the current era, where almost all human activity depends on the internet, international calls, data transmission, banking networks, and satellite surveillance, few people stop to think that the core of this global connectivity is supported by a network of cables lying silently on the ocean floor. Submarine fiber optic cables, thousands of kilometers of technology stretched across all the seas of the world, form the invisible nervous system of the 21st century. What very few know is that this network has been the victim of mysterious cuts, sudden failures, and unexplained disconnections that have, on more than one occasion, left entire countries isolated. The phenomenon of severed submarine cables is not new. Since the first telegraph cables were laid in the 19th century, there have been damages caused by natural factors such as earthquakes, tectonic movements, or underwater volcanic activity. However, in the last 2 decades, there has been a notable increase in unexplained cuts occurring in areas without significant seismic activity or extreme weather conditions. The most unsettling aspect is that, in many cases, the responsible parties are never identified. One of the most discussed events occurred in the year 2008, when several countries in the Middle East and South Asia, including Egypt, India, Pakistan, and Kuwait, partially lost access to the internet and communication networks. Initially, it was thought to be a technical failure, but analyses showed that 4 major cables had been cut almost simultaneously, all in different but strategic locations. The impact was immediate. Financial services paralyzed, international calls interrupted, and data traffic losses exceeding 70% in some regions. The temporal and geographical coincidence of the cuts raised suspicions of intentional sabotage. However, official investigations could not confirm this hypothesis. It was suggested that ship anchors might have caused the damage, although there were no reports of maritime traffic near the locations at the time of the cuts. Others pointed to maintenance errors, but the fact that the incidents occurred at different points and almost simultaneously weakens that explanation. Since then, the cuts have become more frequent. In the year 2012, 3 cables were damaged in the Red Sea. In 2017, the Canary Islands experienced partial disconnection after the rupture of a key link. In 2022, the Faroe Islands were momentarily left isolated due to the inexplicable severing of their only international link. In 2023, 2 cables connecting Taiwan with Japan and the Philippines were cut almost simultaneously. The Taiwanese government declared that it did not rule out the possibility of intentional attack. The official causes often cited include fishing activities, ship movements with improperly secured anchors, underwater landslides, and minor geological events. However, what generates unease is that ship positioning records do not always match the exact location and time of the damage. Furthermore, modern submarine cables are designed to be highly resistant, with several protective layers, pressure shielding, and anti-torsion technology. Although not indestructible, they should not be easily severed by accident. In some cases, damaged cable segments have been recovered and determined to have been cut with precision, suggesting the use of specific tools beyond common environmental accidents. This has fueled speculation about covert submarine sabotage operations, especially in the context of geopolitical tensions. Submarine cables are extremely sensitive targets. Unlike satellites, which can be tracked and monitored easily, cables are vulnerable, difficult to protect, and extend over more than 1,200,000 kilometers across the planet. They carry more than 95% of international data traffic. This includes banking transactions, stock market operations, diplomatic communications, military information, scientific transfers, and more. A cut in the right place at the right moment can generate instant chaos. Cybersecurity specialists warn that there is no efficient global monitoring system for these cables. Most belong to private telecommunications consortia, and governments rely on bilateral or regional agreements for their protection. In theory, any actor with deep immersion technology, a nation, a well-funded organization, or even a private corporation, could approach a cable, interfere with it, cut it, or install listening devices without being detected. In fact, some leaked reports in recent years have revealed that certain governments have installed clandestine interception stations on specific cables to spy on international data traffic. The possibility of intervention is not science fiction. It has already been done. In this context, cable cuts may not simply be accidents, but covert tests, hybrid warfare maneuvers, or vulnerability assessments. Another element that intensifies concern is that submarine cables are not distributed uniformly. There are strategic areas where multiple links converge, known as choke points. One of the most important is the Luzon Strait, between Taiwan and the Philippines. Another is the Suez Canal, through which vital connections between Europe and Asia pass. In these locations, damage to one or two cables can trigger domino effects on a continental scale. Furthermore, with the increase of digital commerce and the development of economies completely dependent on connectivity, submarine cables have become critical infrastructure without adequate military protection. Despite their importance, there are no specific international treaties regulating their defense in times of conflict, leaving them exposed to unconventional operations. The lack of transparency also fuels the mystery. Many incidents are not publicly reported immediately. They are handled as technical matters, announced after several days, and rarely explained in detail. This opacity has led to the circulation of alternative theories, ranging from commercial sabotage to interference by experimental technologies. Some theories even mention the possibility of intelligent marine creatures, such as giant squids or unidentified species interacting with the cables, although this idea lacks solid scientific evidence. Nevertheless, it is true that some animals react to electromagnetic fields, and there have been anecdotal records of sharks biting active cables, mistaking the signals for live prey. However, these attacks do not explain the multiple, simultaneous, and precise cuts recorded in recent events. Today, the matter has begun to draw the attention of defense and international security agencies. The North Atlantic Treaty Organization, the European Union, and several Asian nations have issued reports warning of the need to protect submarine cables against possible covert aggressions. The idea of a war of silence, where communication is disrupted without firing a single bullet, is no longer dystopian fiction. It is a real and growing threat. In summary, the mysterious severing of submarine cables is not simply technical failures. They are a reminder that the most vital infrastructure of the modern world lies on the ocean floor, out of sight and out of reach for most, vulnerable to natural factors, human intervention, and perhaps still unknown forces. The Puerto Rico Trench, a place of inexplicable anomalies. Throughout the Caribbean, just north of the island of Puerto Rico, lies one of the deepest and most mysterious geological formations of the Atlantic Ocean, the Puerto Rico Trench. This oceanic trench, little known outside scientific circles, is a submerged abyss that has drawn attention not only for its depth, but also for the number of inexplicable phenomena reported in its vicinity. The trench has an estimated maximum depth of 8,376 meters, making it the deepest point in the Atlantic Ocean and one of the deepest on the planet. It stretches for more than 800 kilometers, from the northeastern coast of Puerto Rico to the vicinity of the Virgin Islands. Despite its immensity, it has been scarcely explored. Much of its surface remains incompletely mapped, and its marine environment continues to be one of the least understood in the Western Hemisphere. Geologically, the Puerto Rico Trench is the result of the interaction between the Caribbean tectonic plate and the North American tectonic plate. Unlike other more thoroughly studied subduction zones, such as the Mariana Trench, this tectonic boundary is highly complex and does not fit easily into traditional models. In this area, the Caribbean plate slides laterally and partially subducts beneath the North American plate. This movement generates an unusual combination of geological forces, producing earthquakes, fractures, and deformations that are still not fully understood. One of the main anomalies of the trench is its unpredictable seismic activity. Although the region is known to be seismically active, the tremors do not always follow identifiable patterns. Some are shallow, others occur at great depths, and sometimes they seem to arise from zones without visible faults. Moreover, low-frequency seismic events have been recorded, which do not correspond to any known type of conventional earthquake. These events, known as slow earthquakes, release energy without producing destructive waves and could be related to geological processes that remain poorly understood. The trench is also known for its ability to generate tsunamis, even when the triggering earthquakes are not particularly strong. This suggests the existence of underwater landslides or structural collapses of the ocean floor that amplify the displacement of water. Recent studies have found deep depressions and unstable structures on the seabed that could collapse at any time, generating tsunamis without prior warning. However, beyond geology, what has truly sparked interest in this area are the numerous reports of unusual phenomena, including magnetic anomalies, strange behavior of electronic instruments, and inexplicable sightings both in the air and at sea. Various scientific expeditions have reported variations in the Earth's magnetic field when passing over certain sections of the trench. These alterations do not align with typical mineral formations nor with expected subsurface patterns. Deviations in compasses, anomalies in gyroscopes, and even temporary failures in satellite navigation equipment have been documented, all of which return to normal once the vessel moves away from the area. These data have led some to consider the possibility of unusual concentrations of ferromagnetic minerals, or even natural electrical processes that are not yet fully understood. On the other hand, there are more controversial reports that do not come from the scientific community but from commercial pilots, local fishermen, and radar operators. Many of these testimonies consistently describe unidentified lights emerging from or submerging into the ocean at seemingly impossible speeds. Some report objects remaining suspended at low altitude over the sea for long periods, without noise, without visible trails, and disappearing abruptly. These reports, though considered anecdotal by official science, have been repeated with considerable frequency over decades. Some independent researchers have collected historical records dating back even to the early 20th century mentioning unusual activity in this area, long before drones, satellites, or advanced aircraft existed. These observations have led to the Puerto Rico Trench being associated with the so-called Caribbean Triangle, an extended version of the famous Bermuda Triangle, encompassing an area between Puerto Rico, Bermuda, and Miami. In this region, unexplained disappearances of vessels, massive electronic failures in aircraft, and erratic radar trajectories have been reported. Although there is no conclusive evidence directly linking these phenomena to the trench, its proximity to this complex geological area has made many connect them speculatively. A documented case by the United States Coast Guard occurred in 2015, when a cargo plane experienced a total loss of instruments while flying over the northern sector of the trench. The crew, who ultimately landed safely, reported that all digital systems failed for several minutes, including GPS, altimeter, and navigation radar. A subsequent report attributed the incident to undetermined electromagnetic interference. Despite studies conducted, no clear physical cause was found. Additionally, marine biologists working on expeditions near the trench have described unique ecosystems, with species not found elsewhere in the Atlantic. Some creatures collected at depths of more than 6,000 meters display extreme adaptations, such as metallic pigmentation, intense bioluminescence, unknown sensory structures, and metabolisms based on uncommon compounds. These extremophile life forms not only challenge our ideas about the planet's biodiversity, but could also represent evolutionary lineages not yet classified. The lack of systematic studies is one of the factors that perpetuate the mystery. Although the Puerto Rico Trench is relatively close to densely populated coasts and active maritime routes, its exploration has been limited, both for logistical and budgetary reasons. There are no permanent research stations in the area, and deep-sea descent missions have been scarce and brief. This has resulted in the trench remaining largely a void on the oceanographic knowledge map, despite being one of the most accessible deep-sea regions from the American continent. Scientific interest has grown in recent years, but a comprehensive database on its geology, biology, hydrography, or potential geophysical risks is still lacking. Currently, several research groups are proposing international projects to study the trench in depth, including high-resolution scans, missions with unmanned vehicles, chemical analysis of water at different levels, and detection of possible unregistered thermal or seismic emissions. Meanwhile, The Puerto Rico Trench continues to be a place where the scientific, the unknown, and the inexplicable converge. It is a reminder that, even in areas close to our coasts, the ocean still holds secrets. Some may have a rational explanation yet to be discovered. Others, perhaps, may not have one at all. The halting of the Thermohaline current, a warning from the ocean? In the depths of the ocean, hidden from plain sight and often ignored by those living on the surface, operates one of the planet's most powerful and complex mechanisms. The thermohaline circulation, also known as the global ocean conveyor belt. This system of ocean currents not only regulates the planet's temperatures, but also influences weather patterns, biological cycles, and the distribution of nutrients across the entire global ocean. However, in recent years, scientists have begun detecting disturbing signs that this gigantic natural machinery could be slowing down and, in some critical areas, even stopping altogether. The term thermohaline comes from the two factors that drive the circulation: temperature, thermo, and salinity, haline, of the water. Essentially, it is a system in which cold, salty, and therefore denser water sinks in polar regions, while warmer and less salty water rises in the tropics and moves northward along the surface. This movement creates an interconnected network of ocean currents that transport heat from the equator toward the poles and return cold water southward through the ocean's depths. One of the most important components of this network is the Atlantic meridional overturning circulation, which includes the Gulf Stream. This current carries enormous amounts of warm water from the Caribbean to northern Europe, moderating the continent's climate and maintaining relatively mild temperatures even at high latitudes such as Scandinavia and the United Kingdom. Beneath this warm surface current, there is a reverse flow of cold water descending in the North Atlantic and slowly returning south at great depths. This delicate balance has been maintained for thousands of years, but recent studies indicate that the thermohaline current has begun to weaken. Measurements taken by anchored buoys, ocean satellites, and underwater sensors have shown a steady reduction in the speed of circulation. Some climate simulations suggest that the system may be closer to collapse than previously believed just a decade ago. Concern grew significantly in 2021 when a study published in the journal Nature Climate Change revealed that the Atlantic circulation is at its weakest point in at least 1,600 years. The research combined historical data, marine sediments, ice cores, and modern direct observations to conclude that the conveyor belt is losing strength consistently. Although it has not yet come to a complete stop, parts of the system appear to be fragmenting. One of the most alarming areas is the behavior of the so-called sinking point near Greenland, where cold, salty water should descend to the ocean floor. Recent research has detected that surface waters in that zone are becoming less salty due to the accelerated melting of glaciers and the Arctic ice sheet. The fresh water entering the system dilutes salinity, reduces the density of the water, and consequently interferes with its ability to sink. If this disruption continues, it could trigger a domino effect. Warm water would continue to accumulate at the surface, without cold water taking its place in the depths. The result would be a progressive slowdown of the entire thermohaline system. Some models suggest that a partial or total collapse could occur within this century if greenhouse gas emissions and polar melting continue at their current accelerated pace. The potential impacts of such an event are difficult to overstate. A substantial disruption of the thermohaline circulation would drastically alter global climate. Western Europe could experience much colder winters, while sub-Saharan Africa and regions of the Caribbean could face prolonged droughts. The South Asian monsoon, upon which millions depend, would become erratic. Furthermore, sea levels along the eastern coast of North America could rise faster than expected due to changes in the currents that currently help keep them relatively contained. In the South Pacific, a weakening of heat transport would change the dynamics of El Niño and La Niña, affecting rainfall and temperature patterns in South America, Australia, and Southeast Asia. In the Northern Hemisphere, atmospheric jet streams would also be altered, causing more frequent and severe weather extremes. In other words, a change in submarine currents could translate into climatic chaos on the surface. Beyond atmospheric impacts, the halting of thermohaline circulation would also have profound ecological consequences. Many marine species depend on deep currents for the distribution of nutrients and oxygen, as well as for multiple stages of their life cycles. If deep waters cease to move, some regions of the ocean could experience dead zones, areas without oxygen where marine life simply cannot survive. Historically, there is evidence that something similar has happened before. During the so-called Little Ice Age, between the 14th and 19th centuries, temperatures in Europe dropped significantly, and some geological records suggest this may have been linked to a temporary slowdown in ocean circulation. In even earlier periods, such as the Younger Dryas event around 12,000 years ago, it is believed that a sudden stoppage of the thermohaline circulation caused an abrupt global cooling within just a few decades. The difference today is that the phenomenon would not be driven by natural cyclical causes, but by human activity. The melting of polar ice, the warming of ocean waters, and the massive release of freshwater are direct consequences of global warming, and their effect on ocean circulation is occurring over a geologically short time span. Despite everything, there is no absolute consensus on when or how the thermohaline circulation might completely halt. Some more optimistic climate models indicate that the system could stabilize if emissions are reduced and global warming is mitigated over the coming decades. Others argue that we have already crossed points of no return, and that the deceleration processes are irreversible within human timescales. In 2023, a joint study by European and American scientists proposed that the Atlantic meridional overturning circulation could collapse between 2025 and 2095, depending on several critical factors. This range is wide, but it suggests that we are not talking about a distant or hypothetical phenomenon, but about something that could happen within the lifetime of current generations. Even more unsettling is that no one can predict with certainty the exact effects of such a collapse, due to the complexity of the global climate system. There are many interdependencies, and the behavior of the atmosphere, oceans, and biosphere is so intricate that small variations could generate enormous consequences. In this context, the question remains, are we witnessing a warning from the ocean? Is this deceleration an early signal of a large-scale planetary shift? Or is it merely a temporary oscillation that will eventually correct itself? Today, the oceans are already sending signals. Marine temperatures break records year after year, ice sheets are melting at unprecedented speeds, and the equilibrium of climate systems is being disrupted. The possible halting of the thermohaline current is not just a scientific mystery, it is an existential challenge. The Java Trench noise, pressure, and unknown life. In the vast Indian Ocean, just south of the island of Java, Indonesia, stretches one of the deepest, least explored, and most puzzling regions on the planet. The Java Trench, also known as the Sunda Trench. Despite its enormous size, more than 3,200 kilometers long, and its proximity to one of the most densely populated regions of the world, the Java Trench remains one of the greatest enigmas of the deep ocean, with features that even today challenge the understanding of geologists, marine biologists, and sound physicists. The trench reaches a maximum depth of 7,725 meters, making it the deepest point in the Indian Ocean. This underwater depression marks the boundary between the Australian tectonic plate, which is sliding northward, and the Eurasian plate, which forms part of the Indonesian archipelago. This subduction zone is highly active and has been responsible for some of the most devastating earthquakes in recent history, including the Sumatra Andaman earthquake of 2004, which triggered a tsunami that claimed more than 230,000 lives across 14 countries. Geologically, the Java Trench is an extremely dynamic place. The Australian plate sinks beneath the crust of Java at a rate of approximately 6 centimeters per year, causing the buildup of stresses that eventually release in the form of megathrust earthquakes. However, the movement of these plates is not uniform, and seismic models have revealed unexpected irregularities. Some parts of the seabed appear to be more fractured than others, and certain sections exhibit atypical seismic behaviors, such as silent ruptures that do not produce perceptible surface vibrations. But beyond its tectonic activity, what has begun to capture the attention of scientists is what happens in its extreme depths. During recent expeditions, researchers have recorded unexplained sounds emanating from within or near the trench. These noises, captured by long-range hydrophones, do not match any known seismic pattern nor fit the catalog of sounds produced by common marine species, such as whales or giant squids. Some of these sounds have extremely low frequencies, almost inaudible to the human ear, but powerful enough to travel hundreds of kilometers through the water. One of the most intriguing recordings, informally known as the Sunda Moan, was captured in 2016 by a team of oceanographers monitoring seismic activity in the region. The sound consisted of a descending frequency pulse, repeated rhythmically for more than 8 minutes, with an unusual intensity compared to the natural background noise of the deep ocean. When analyzed by marine acoustic experts, it could not be attributed to either geological processes or known marine fauna. Although some proposed it could be a collapsing cavern at great depth, others pointed out that the pattern was too orderly to be purely random. The pressure in the Java Trench is extreme. At more than 7,000 meters below the surface, every square centimeter is subjected to approximately 770 times the atmospheric pressure at sea level. Any form of life dwelling there must withstand constant crushing pressure, complete darkness, and temperatures near freezing. Yet life exists. In 2018, a joint expedition between Japanese and Indonesian researchers used a remotely operated vehicle to descend more than 6,500 meters. What they found defied all expectations. In the recorded images appeared organisms with completely unusual forms. Scaleless, translucent fish with gelatinous bodies adapted to the pressure, crustaceans that seemed to have lost all pigmentation, and microorganisms colonizing rocks that exuded compounds rich in heavy metals. Some of these creatures did not correspond to any species previously catalogued. The marine biologists who analyzed the findings concluded that at least 5 species were entirely new and could form part of an ecosystem deeply isolated for thousands or even millions of years. One particularly intriguing discovery was a colony of microbial organisms that appeared to feed directly on sulfur compounds and methane, in the total absence of sunlight. This type of metabolism is rare, but not unprecedented. It has been documented at hydrothermal vents elsewhere in the world. However, the Java Trench does not present evident surface volcanic activity, suggesting that there may be undiscovered underground sources of heat and chemical energy, possibly linked to deep fractures or leaks from the Earth's mantle. Additionally, some rock fragments recovered during the missions showed signs of partial vitrification, meaning areas where the rock had been exposed to temperatures so high that it began to melt. Strangely, there is no documented volcanic activity in the sampling zone. This led some researchers to hypothesize that certain areas of the trench might harbor thermal processes not yet understood, such as sudden releases of heat from deep underground chambers, or the rapid collapse of pressurized layers generating frictional heat. From an oceanographic perspective, the Java Trench also presents anomalies in deep currents. Measurements have revealed that water masses in its depths do not follow completely predictable trajectories. In some sections, slow, persistent whirlpools have been detected, changing direction without a clear pattern. These movements could be related to the irregular topography of the ocean floor or to interactions between thermal layers and extreme salinity. However, the lack of data currently prevents a firm conclusion. Another worrying phenomenon is the presence of accumulations of microplastic debris in the deepest zones of the trench. Despite being thousands of meters below the surface, sensors and cameras have detected artificial particles mixed with natural sediment. This demonstrates that human-generated pollution has reached even the most inaccessible points of the Indian Ocean, affecting ecosystems that, until recently, were believed to be untouched. In terms of exploration, the Java Trench remains a tremendous logistical challenge. The conditions of pressure, darkness, and depth require costly technologies, and the resources allocated to its study have been limited compared to other better-known trenches. There are no permanent research stations in the area, and deep-sea missions have been sporadic and brief. All of this has made the Java Trench an ideal space for mysteries. There has been speculation about the existence of submerged caverns, completely isolated ecosystems, or even anomalous geological structures. Although many of these ideas are difficult to verify with current means, the fact that such a vast region remains almost unexplored is itself a reflection of how much we still have to learn about the planet. The Java Trench is not just a deep hole at the bottom of the sea. It is a living archive of geological, biological, and climatic processes that we are only beginning to comprehend. With each descent, new forms of life, new structures, and new behaviors are discovered that contradict our expectations. It is a silent reminder that beneath the surface of the ocean, an undiscovered Earth still awaits. The perfect circles on the Japanese seafloor, works of art created by fish or something else. In the coastal waters of southern Japan, in the sea near the region of Amami-Oshima, a phenomenon as unusual as it is beautiful was discovered. About 25 meters deep, on the sandy seabed, appear circular structures of almost perfect geometry, carved with a complexity that seems to defy natural logic. These formations, often compared to crop circles, measure between 1.5 and 2 meters in diameter and display radial designs, symmetrical patterns, concentric ripples, and small ornamental ridges, as if someone had drawn them with a giant compass beneath the water. The most unsettling aspect is not only their precision but also the fact that these figures are not static. They appear, disappear, and re-emerge, always with slight variations. For years, divers who encountered these underwater drawings were left perplexed. The scientific community, for its part, was slow to find a convincing explanation. Early theories were as diverse as they were baffling. From formations caused by unusual underwater currents to the possibility of tectonic activity generating vibration patterns. Some even mentioned the hypothesis of non-human intelligence, given the level of complexity and symmetry exhibited by the designs. It was not until 2012 that the mystery began to be partially resolved, thanks to a series of underwater observations conducted by a Japanese team led by the marine photographer and documentarian Yoji Ukeda. Equipped with high-definition cameras and extended dive times, Ukeda managed to capture on video the entire construction process of one of these underwater circles. To the surprise of many, the creator was a small male pufferfish, belonging to a previously unknown species within the family Tetraodontidae. The fish, barely 12 centimeters long, used its fins to move the sand with extreme precision, first creating a base circle, and then tracing grooves and ridges radiating from the center to the edges. Additionally, it inserted small shells and stones at specific points within the design, apparently as part of a strategy to attract a female. According to the biologists who analyzed the behavior, this was a courtship structure, a kind of display nest designed to increase the chances of reproduction. The discovery, though fascinating, raised even more questions. The complexity of the structure was not only visually striking but also seemed to fulfill specific engineering functions. The ridges helped channel water currents, reducing the flow of sand into the nest center and creating a more stable microenvironment. The hard objects placed at key points served as anchors or perhaps as markers for the female. It had become clear that one of the most sophisticated architectural behaviors in the animal kingdom was being carried out by a solitary fish, without tools, without training, without imitation, purely with instinct and precision. However, despite this zoological explanation, the phenomenon remains not completely closed. Direct observations could only confirm the authorship of a portion of the circles found in the region. Other patterns, discovered in deeper areas or with different configurations, have not been conclusively linked to the same species. Some exhibit different structural details, more elongated shapes, spiral patterns, or elements that do not match the documented behavior of the known fish. Moreover, there are historical records from local divers and fishermen who claim to have seen similar circles decades earlier, even at depths and locations where the identified species does not typically reside. This has led some researchers to consider that other species with similar abilities yet to be observed might be responsible, or that entirely different formation mechanisms could be at play. Another line of investigation suggests that certain conditions of the seabed, specific combinations of sediments, currents, and seismic vibrations, could, in theory, generate complex geometric patterns naturally. These patterns, known as self-organized morphologies, have been observed in some terrestrial environments, such as dunes or salt flats, though with much less symmetry. Applying this idea to the seabed would, however, require highly specific conditions, difficult to replicate. Interest has also emerged around the possibility that these formations could be part of collective or communicative behaviors still not fully understood. In other animal species, such as birds or insects, complex patterns are used to mark territory, transmit signals, or deter predators. In the underwater environment, where visibility is limited and sounds propagate differently, shape and design could play a communicative role, especially among benthic species, those living close to the seafloor. There has even been a speculative hypothesis about a form of non-human cultural transmission. The idea that these fish might pass on the design between generations, not as pure instinct but as a learned behavior. If proven, this would point to a type of animal culture far more complex than traditionally accepted, something that has only been confirmed in species like dolphins, elephants, and some primates. On the other hand, the visual component of the phenomenon has reignited the old debate about the relationship between natural patterns and sacred geometry. Since ancient times, humans have associated circular symmetry with perfection, balance, and hidden messages. Some see in these marine circles a direct analogy to mandalas, symbols of meditation, or even representations of natural acoustic resonance, similar to the forms created by sound on liquid surfaces under controlled conditions. Despite their apparent simplicity, the process of constructing these circles is demanding. The fish can take between 7 and 9 days to complete the design, working day and night, maintaining the structure against currents and external disturbances. Once a female is attracted and reproduction occurs, the circle quickly degrades. The fish abandons it, and the pattern is eventually erased by the tide. This makes these works ephemeral structures, artistic and functional at once, like sand sculptures in constant motion. Today, scientists continue to investigate the diversity of these patterns, the possible existence of other builder fish, and the environmental factors that may influence the designs. Long-term underwater cameras have been installed, and some autonomous robots are beginning to map wider regions in search of new examples. What began as an aesthetic curiosity, a submarine rarity documented by amateur divers, has evolved into a serious field of interdisciplinary study, connecting biology, physics, mathematics, and natural philosophy. The circles on the Japanese seabed continue to appear and disappear in silence. They are wordless messages, functional works of art created by tiny creatures, but with a precision that leaves the human observer in awe. And although some now have an explanation, others still remain without a recognized author, reminding us that even in relatively shallow waters, the ocean continues to guard perfectly drawn secrets on the sand. The Soviet submarine K-129, a shipwreck that was never fully explained. Within the archives of the Cold War, there exist incidents surrounded by secrecy, contradictory theories, and incomplete official versions. One of the most perplexing occurred in 1968, in the vast and silent North Pacific Ocean, thousands of kilometers from any coast. In that immensity, the Soviet submarine K-129 disappeared without emitting any distress signal, leaving behind a void and a chain of questions that, more than 5 decades later, still remain unresolved. The K-129 was a Gulf II-class submarine, powered by diesel-electric engines and armed with nuclear ballistic missiles. It formed part of the strategic arsenal of the Soviet Union, tasked with maintaining a deterrent presence in the open sea in case of nuclear conflict. On the 24th of February 1968, it set sail from the base at Petropavlovsk on the Kamchatka Peninsula for what was supposed to be a routine patrol. It carried 98 crew members and was scheduled to operate in a zone known as Patrol Pattern 7, north of Hawaii. What happened afterwards still lacks a clear official explanation. The K-129 suddenly ceased all communication in March of that year. The Soviet Navy received no emergency signals nor detected any signs of sabotage or attack. After multiple failed attempts to establish contact, the submarine was declared lost, although the Union of Soviet Socialist Republics kept its disappearance secret for weeks. Meanwhile, the United States, which maintained an extensive network of underwater sensors across the Pacific Ocean, known as the Sound Surveillance System, detected an unusual acoustic signal on the 8th of March, 1968. The recording, captured by multiple stations, corresponded to a submarine explosion at great depth. Its location was triangulated, approximately 2,800 kilometers northwest of Hawaii, in a zone outside the usual Soviet patrol patterns. The coincidence with the disappearance of the K-129 was soon suspected by United States naval intelligence. From there, a secret operation began that would later be revealed as one of the most ambitious and mysterious maneuvers in modern naval history. Project Azorian, conducted by the Central Intelligence Agency. The objective was simple in concept but monumental in execution: to locate the wreckage of the sunken Soviet submarine at a depth of over 5,000 meters and recover it without the Soviet Union realizing it. The possibility of obtaining Soviet secret technology, communication codes, nuclear torpedoes, and classified information about intercontinental missiles was too tempting to ignore. To achieve this, the Central Intelligence Agency resorted to a covert strategy: the construction of a supposedly civilian ship, publicly financed by magnate Howard Hughes, called the Glomar Explorer. According to the official narrative, the vessel was designed to conduct mining of metallic nodules from the ocean floor. In reality, it was a highly specialized underwater recovery platform, equipped with cranes, mechanical arms, and a capture capsule system designed to retrieve the submarine without breaking it apart. In 1974, after years of planning and an estimated cost of over $350 million of the time, the Glomar Explorer reached the exact site where the sound surveillance system had located the explosion 6 years earlier. Using technology never before tested at that depth, the capsule reached the seabed and, allegedly, engaged the remains of the K-129. However, during the ascent, a structural failure caused 2/3 of the submarine to detach and fall back to the bottom, while a smaller section, including several central compartments, was successfully recovered. What exactly was extracted has never been fully revealed. According to the officially declassified version, no functional nuclear weapons, communication codes, or valuable intelligence were recovered. However, several former intelligence officials have suggested that confidential documents, navigation systems, missile components, and even crew remains were indeed retrieved, and that a formal burial at sea was carried out. The Soviet Union, for its part, never publicly confirmed that the K-129 had been found by the United States, although privately they were aware that the Glomar Explorer was no ordinary mining vessel. Years later, after the fall of the Soviet bloc, former Russian officials expressed their belief that the partial recovery of the submarine had been successful, and that Washington had gained access to highly sensitive materials. Yet the most unsettling questions revolve around the exact circumstances of the sinking. The submarine's location did not match its assigned patrol area. There were no signs of collision with another object, nor evidence of a direct attack. Some theories suggest an internal accidental explosion, perhaps related to a failure in the missile launch system. Others propose a mutiny aboard, or even a covert mission beyond the knowledge of the Soviet High Command. One of the most controversial theories, supported by some American intelligence analysts, is that the K-129 may have attempted to launch a nuclear missile on its own, perhaps as an act of defiance or a failed attempt to provoke an international incident. This speculative version is based on the depth of the structural damage, the lack of distress signals, and the fact that the submarine was so far from its assigned area. However, no public evidence confirms this hypothesis. Another theory suggests that the K-129 collided with an American submarine, specifically the USS Swordfish, which, according to historical records, was operating in the Pacific at that time. The Swordfish returned to port shortly thereafter with damage to its bow, officially attributed to an ice collision. However, some Russian investigators assert that the damage was more consistent with a metallic impact, possibly with the hull of another submarine. If this were the case, the collision might have been accidental or deliberately concealed. Despite all the reports, declassified documents, and interviews, no explanation has been entirely satisfactory. The case of the K-129 remains one of the most enigmatic shipwrecks of the Cold War, shrouded in a web of geopolitical interests, nuclear rivalry, military secrecy, and unconfirmed theories. Today, the remains of the submarine still lie at the bottom of the Pacific Ocean, in an area that remains inaccessible to conventional expeditions. Only a small portion was rescued, and what that section revealed or did not reveal remains classified. What began as the silent disappearance of a submarine on patrol ended as an unprecedented intelligence operation and a mystery that still raises suspicions on both sides of the former Iron Curtain. The South Pacific Silent Zone, where the sea seems to shut down. Amid the vast Pacific Ocean, far from shipping routes, inhabited coasts, or military bases, there exists a sector known among oceanographers and navigators as the South Pacific Silent Zone. Although it is not officially delineated by precise coordinates, numerous reports over the past decades have identified a broad oceanic stretch where sound, marine activity, and even certain electronic records seem to vanish or diminish inexplicably. This zone, extending roughly between the 30th and 40th parallels south and east of New Zealand, is not known for violent storms nor for obvious navigational dangers. What makes it unique is its anomalous behavior in several aspects. A notable scarcity of observable life, an unusual acoustic silence in underwater recordings, interference with radio signals, and a recurring pattern of technical failures in oceanographic instruments. One of the earliest documented observations of this phenomenon dates back to the 1960s, when American scientists were conducting acoustic monitoring of the Pacific Ocean as part of the global system for detecting underwater nuclear tests. Using a network of hydrophones distributed across the seafloor, they detected that at certain times, sounds that would normally travel thousands of kilometers underwater, such as those generated by whales, earthquakes, or even distant explosions, would suddenly attenuate or disappear when passing through this region. Initially, it was thought that the phenomenon was caused by unusual propagation anomalies triggered by specific thermal conditions in the water. In the ocean, sound travels most efficiently through areas known as deep sound channels, where pressure and temperature interact to guide acoustic waves over great distances. However, thermal models of this zone showed no significant variations to justify such an absorption level. The sound simply ceased to be recorded with the expected intensity. As scientific expeditions to this part of the Pacific increased, other puzzling elements began to emerge. In missions involving automatic probes and autonomous underwater vehicles, researchers reported recurrent sensor failures, loss of GPS signal, errors in digital compass readings, and in some cases, temporary blackouts of electrical systems aboard without any apparent cause. On land, monitoring teams identified intermittent communication cuts and a decrease in the transmission intensity of data originating from that area. These technical failures might seem isolated or explainable if not for their consistent repetition, always in the same region, and always under stable environmental conditions. No evidence of submarine volcanic activity has been found, nor have dangerously anomalous magnetic fields been detected. However, some studies have revealed slight but unusual variations in the local magnetic field, not corresponding with normal Earth activity at that latitude. The biological aspect further deepens the mystery. Images obtained by deep exploration cameras show a remarkable scarcity of marine life compared to other regions of similar latitude and depth. While benthic life, organisms living near the seafloor, is observed, the density of fish, jellyfish, squid, and other pelagic species is lower than expected. Furthermore, the usual migratory routes of cetaceans seem to avoid this area, even though its location would logically be part of their transoceanic paths. One of the most discussed, though yet unverified, hypotheses is that this silent zone could correspond to an area of extreme natural acoustic absorption, caused by a combination of factors still not fully understood. Opposing submarine currents, overlapping layers of salinity, suspended microbubbles, or even seabed materials that absorb rather than reflect sound waves. Nonetheless, no mathematical model has yet been able to successfully reproduce the exact conditions observed in this region. For instance, no firm correlation has been found between the water column structure and the recorded acoustic signal loss. Nor have any mineral deposits been identified that could explain the unusual absorption of electromagnetic waves, which, although already poorly transmitted through water, show even greater weakening in this sector. Speculation, of course, has gone far beyond strict scientific inquiry. Some independent researchers have suggested that this region might contain some kind of unknown geological structure, such as a collapsed cavern beneath the seafloor or a formation composed of highly absorbent materials. Others have proposed the possibility of a bubble of trapped gas within sedimentary layers, which could interfere with acoustic waves or produce electrostatic discharges through fractures in the seabed. As with many other deep ocean phenomena, more daring theories have also surfaced. One proposes that the zone could act as a geophysical window between different layers of Earth, where conditions of pressure, gravity, or even time are subtly altered, causing inexplicable technical failures. This theory lacks solid scientific backing but has attracted attention from those who study global geophysical anomalies. Still others go further, linking the zone to historical accounts from sailors of past centuries. Disappearances, involuntary course changes, erratic meteorological records, and even sightings of submerged lights ascending at high speed. Although these stories reside at the fringes of science, it is noteworthy that the region has attracted even military interest. Some analysts point out that the area partially coincides with historical submarine test zones, both by the United States and other powers. This has led to speculation that the region could have been the site of deep communication technology experiments, long-range sonic tests, or electromagnetic emissions that left residual effects in the environment. While there is no public evidence to confirm this, the inherently classified nature of such activities leaves room for uncertainty. More recently, in 2019, a joint oceanographic mission by scientists from New Zealand and South Korea attempted to systematically study the zone using next-generation autonomous vehicles. Preliminary results showed altered acoustic readings, reduced active sonar reflection, and temporary signal loss in 3 of the 6 deployed drones. The full reports have not been published, further fueling questions about what was actually discovered during that expedition. As of now, there is no definitive conclusion about what exactly happens in the South Pacific Silent Zone. Research continues, but access is difficult, funding is limited, and scientific priority often falls on regions with more immediate ecological or economic impact. Nevertheless, for those who have studied the ocean for years, this place represents one of the planet's purest enigmas. It poses no immediate threat, it does not seem to harbor evident physical danger, but it operates as a natural blackout within the global system, where instruments fail, sound dissipates, and life appears to retreat. Perhaps the explanation lies in some yet unknown property of deep water. Or perhaps, as with other marine mysteries, it is a combination of factors coinciding at the right place and time, creating a unique phenomenon. Meanwhile, the South Pacific continues to guard its silence, and in the midst of the nothingness, in the endless blue that looks identical in every direction, there is a zone where everything vanishes, without noise, without explanation, without witnesses. The fossil reefs of the depths, evidence of ancient sea levels. In the deepest parts of the oceans, where light no longer reaches and temperatures hover near freezing, exploration vehicles have revealed structures that, at first glance, should not exist. Formations of fossilized coral, lying hundreds, and in some cases, thousands of meters below today's sea level. These formations, known as deep fossil reefs, have baffled oceanographers, marine geologists, and paleoclimatologists alike. Their existence raises a crucial question. How did corals, organisms dependent on sunlight, come to build themselves at such depths? And what do these petrified remains tell us about the planet's ancient past? Unlike modern corals, which thrive primarily in warm, shallow waters where they receive enough sunlight to sustain their symbiosis with photosynthetic algae, these fossil reefs are located at depths ranging from 150 to 1,200 meters, where sunlight cannot penetrate and modern coral life would be impossible. This certifies that these corals did not grow there by chance. They formed during periods when sea levels were dramatically lower, and today's submerged continental shelves were exposed or existed as shallow zones. The discovery of these reefs is not recent, but their significance has grown exponentially in recent years, thanks to the development of high-resolution seabed mapping technologies and the proliferation of autonomous deep exploration vehicles. Numerous studies in the Gulf of Mexico, the Caribbean Sea, the Indian Ocean, and along the western Pacific coast have revealed long chains of fossilized coral structures, some stretching for tens of kilometers, remarkably well preserved. One of the most surprising characteristics of these reefs is their arrangement. In many cases, they form step terraces, as if frozen at different moments when sea levels temporarily stabilized during glacial periods. This has led scientists to consider them as living geological records of climate change over the last hundreds of thousands of years. During glacial periods, vast volumes of water were trapped in the form of ice over the continents, causing dramatic sea level drops, sometimes more than 100 meters below the current level. During these intervals, many areas that are now fully submerged were coastal platforms, sandy banks, or even islands. It was in these regions that corals thrived, forming reefs much like those found today. As the climate warmed and the ice melted, sea levels rose and gradually submerged these living structures, cutting them off from light and suitable conditions, resulting in their death and fossilization on the seafloor. But beyond confirming past climate processes, what is unsettling is that some of these formations are found at depths that do not fully match current models of glacial retreat. In other words, certain fossil reefs are located at depths where, according to known climatic estimates, sea levels should never have dropped low enough to expose those zones. This has prompted several explanations, none of them fully verified. One theory suggests that these reefs formed in tectonically active areas where subsequent geological movements sank sections of the Earth's crust, pushing the original reefs to greater depths. This possibility makes sense in regions like Southeast Asia or the Western Indian Ocean, where tectonic plate interactions are constant. However, in tectonically stable areas such as parts of the Atlantic Ocean, this explanation falls short. A more recent line of investigation considers the existence of massive submarine sinkholes or geological collapses, where an entire platform could have descended hundreds of meters due to internal failures in the sediment or the dissolution of soluble materials beneath the seabed. These depressions, known as slumps, could explain why some reefs are much deeper than expected. Nevertheless, the regularity with which reef terraces appear at different depths across various oceans suggests that, beyond local processes, there is a global pattern not yet fully understood. Some fossil reefs found in deep waters of the Red Sea and the Pacific Ocean also present chemical anomalies. In their composition, unusual ratios of certain oxygen and carbon isotopes have been found, indicating climatic or oceanic chemical conditions during their formation that differ from those of today. Layers of volcanic material have also been detected between coral formations, suggesting that some reefs may have been rapidly buried by catastrophic events such as submarine eruptions or tsunamis, rather than a slow, gradual sea level rise. Beyond their value as witnesses to geological history, these fossil reefs are beginning to reveal information about the lost biological history of the oceans. In some fragments, calcified skeletons of extinct coral species and other marine organisms have been found, with no known modern equivalents. This has led to theories that entire coastal ecosystems vanished before the Holocene, erased by rising sea levels or drastic changes in ocean chemistry. Even in their dead forms, these reefs still influence the present. They serve as secondary habitats for deep-sea species and, in some cases, act as natural sediment and microplastic traps, playing a passive role in seabed filtration. However, human activities, such as deep-sea trawling, mining exploration, and drilling, have begun to damage these formations before they can be fully studied. Some scientists have proposed using these fossil reefs as climate alert indicators, as their depths and compositions can help refine current models of sea level rise. For example, studying the growth and death rates of corals in different strata could reveal with greater precision the speed of polar ice melt in the past, which is crucial for predicting how sea levels might evolve in the coming decades. More speculative voices suggest that the alignment of certain fossil reef systems with submerged ancient riverbeds might point to prehistoric coastal civilizations now lost beneath the ocean. While these claims have not been scientifically verified, the discovery of lithic structures near ancient reef systems has sparked debate about possible human occupations on submerged platforms, especially during the last 20,000 years. What is clear is that deep fossil reefs are archives of Earth's past, hidden for millennia and only now beginning to tell their story. They are not random remnants nor geological whims. They are structures built by millions of living organisms, layer upon layer, over thousands of years, now lying petrified in darkness. Their distribution, composition, depth, and preservation challenge our understanding of climatic cycles, geological change rates, and the boundaries of human and animal habitats across time. The brine lakes at the bottom of the ocean, rivers within the sea. When we imagine the ocean floor, we usually picture a dark, uniform, and silent landscape where everything is covered by a seemingly homogeneous mass of water. However, explorations over the past decades have revealed a far stranger and more unexpected reality. Within the ocean itself, there are separate bodies of water, lakes, and rivers that flow across the seafloor, with clearly defined shores, visible waves, and even distinguishable coastlines. These phenomena are known as brine lakes and represent one of the most surprising and enigmatic discoveries of modern oceanography. Brine lakes are accumulations of extremely salty and dense water that settle into depressions on the seafloor, forming stable pools that do not mix with the surrounding seawater. The difference in density between the brine and the ocean water causes these formations to behave as if they were separate liquids, creating the illusion of a sea within the sea. Most astonishingly, these lakes often have flat surfaces, marked shores, sedimentary banks, and even internal currents. The discovery of these underwater lakes began in the mid-1980s, but gained wider attention following a series of explorations conducted in the Gulf of Mexico and the Mediterranean Sea during the 1990s. One of the most studied sites is Orca Basin in the Gulf, located about 2,000 meters deep. There, using manned submersibles and remotely operated vehicles, scientists discovered a pool approximately 20 meters in diameter, whose waters contained nearly 5 times the salinity of normal seawater. The scene was so surreal that the first explorers to descend described encountering a submarine coastline, complete with gentle waves, surface bubbling, and a sharp line separating the brine from the surrounding ocean. Probes attempting to penetrate the surface of the lake initially bounced off, as if striking a membrane, and only after applying constant pressure could they pierce the boundary. This behavior results from the density contrast between the two fluids. The brine is so dense that it acts as a physical barrier, maintaining its distinct form even under the immense pressure of the deep sea. In addition to salt, these waters contain high concentrations of methane, hydrogen sulfide, ammonia, and other chemical compounds, many of which would be lethal to conventional forms of life. And yet, in these extreme environments, life not only exists, it thrives in unimaginable ways. Along the shores of these brine lakes, scientists have discovered unique biological communities composed of bacteria, archaea, and some types of invertebrates that have evolved to survive without oxygen, without light, and in chemical concentrations that would destroy nearly any other organism. These microbes do not rely on photosynthesis but instead use chemosynthesis, extracting energy from transforming chemical compounds like methane and sulfur. This is the same type of metabolism found around hydrothermal vents, but here it occurs in even more chemically aggressive conditions and with an even greater diversity of unknown organisms. One of the most significant findings was the discovery of organized microbial mats, authentic biofilms that coat the lake edges, forming complex structures that function as closed ecosystems. In some cases, researchers have even documented the presence of small worms, adapted crustaceans, and larvae inhabiting the interface between normal seawater and the brine, as if living at the boundary between two worlds. Most surprisingly, some of these organisms have developed molecular mechanisms to tolerate extreme pressure and high concentrations of toxins, making them potential models for biotechnology and medicine. Indeed, certain compounds produced by these bacteria have shown antibacterial or anti-cancer properties currently being studied in laboratories around the world. From a geological perspective, the existence of these lakes can be explained by the dissolution of ancient salt deposits located beneath the seafloor. Millions of years ago, during the Miocene epoch, vast areas of today's seafloor were exposed salt basins, where massive evaporation left thick layers of halite, common salt. Over time, the seas covered these basins again, but in some places, water infiltrating through upper layers has redissolved the salt, creating subsurface brine pockets that slowly emerge onto the seafloor. The process is slow but continuous. Where the seafloor's topography allows, these brine leaks accumulate in depressions to form lakes. In other cases, they flow like underwater rivers, creating channels and basins with subtle but measurable movements. One of the most intriguing examples is a system of interconnected lakes in the eastern Mediterranean's La Talente Basin, where a subsurface current links several brine pools through natural tunnels within the sediment. This phenomenon has sparked comparisons to terrestrial fluvial processes and has led some researchers to propose that we might be looking at a hidden hydrological network within the ocean, composed of fluids with different chemical compositions and physical behaviors. The possibility of studying hydrology within the ocean, in terms comparable to rivers, lakes, and aquifers, is a completely new idea that is reshaping part of contemporary oceanography. But these lakes attract not only biologists and geologists. They are also of great interest to astrobiologists, who view them as analogs for exploring icy moons in the solar system, such as Europa, of Jupiter, or Enceladus, of Saturn. It is suspected that beneath the icy crusts of these worlds lie salty oceans where life could exist. If organisms can survive in Earth's brine lakes, without oxygen, without light, under extreme pressure, and in toxic environments, then extraterrestrial life in similar conditions is not mere fantasy but a real possibility. From a technological standpoint, studying these environments is no easy feat. Submersible vehicles must withstand intense pressures and be equipped with sensors capable of detecting minimal chemical and thermal variations. Furthermore, contact with the brine can corrode equipment in a matter of hours if not properly protected. Thus, exploration of these lakes remains expensive and limited to a few missions per decade. Environmental risks are also considerable. Although these ecosystems are resilient within their contexts, they are extremely sensitive to external disturbances. Introducing oxygen, stirring sediments, or accidental contamination could wipe out entire communities before they are even fully cataloged. For this reason, many scientists have proposed creating marine protected areas around known brine lakes to preserve their unique biological and scientific value. Beyond their academic importance, these underwater lakes serve as a visual and conceptual reminder that the planet still holds secrets worthy of awe, that, in the deepest, most silent and hostile places, water can create new forms of water, that there are lakes within the ocean, invisible coastlines, and rivers flowing in darkness, speaks to the extraordinary and still largely unexplored character of the marine world. The thermal anomaly of the Weddell Sea, inexplicable heat beneath Antarctic ice. In the vast, frozen expanse surrounding Antarctica, where temperatures plunge to extreme lows and the ocean remains covered for most of the year by a thick sheet of sea ice, scientists have detected a phenomenon that defies the logic of such a frozen environment. An anomalous zone of heat located beneath the Weddell Sea, one of the coldest and most remote regions of the southern hemisphere. This thermal anomaly, present hundreds of meters below the surface, has not only raised questions about its origin, but also about its implications for Antarctic ice stability and the future of the global climate. The Weddell Sea lies in the western sector of Antarctica, bordered by the Antarctic Peninsula to the north and the Filchneron ice shelf to the south. It is one of the most studied zones by oceanographers due to its crucial role in the formation of Antarctic deep waters, which feed the global ocean currents. However, it wasn't until the past 20 years, with the use of deep thermal sensors, that scientists began detecting unusual readings in specific areas beneath the ice cap. Significantly warmer water temperatures than expected. These temperatures, recorded at depths between 400 and 800 meters, exceeded typical ambient water values by several degrees Celsius. While at first glance a few degrees might seem negligible, in these conditions even an increase of 1 or 2 degrees is enough to accelerate the melting of ice shelf bases, alter local currents, and even destabilize continental ice masses. The big question was, where is this heat coming from? The first hypothesis was logical. Deep warm currents from the Atlantic could be intruding beneath the ice shelves, channeled by the region's underwater formations. This theory is based on a phenomenon known as the intrusion of circumpolar deep water, a mass of warmer water that circulates at great depth around the Antarctic continent. Under normal conditions, this water remains isolated from the ice shelves. But if it infiltrates through submarine canyons, it could locally raise water temperatures. Ocean models partially support this explanation, but there's a problem. The amount of heat recorded exceeds what would be expected even in the most efficient intrusions of circumpolar deep water. Moreover, the anomaly is persistent and lacks the typical variability seen in ocean currents, suggesting that an additional heat source might be contributing to the phenomenon. Thus emerged a second, more unsettling possibility: geothermal activity beneath the ice. Although Antarctica is often imagined as a geologically inert region, it is in fact crossed by a network of fault lines, latent magma chambers, and volcanic zones hidden under the ice. Recent radar ice penetration studies and seismic readings have revealed more than 100 potentially active volcanoes beneath the Antarctic ice cap, many of them still unexplored. If one of these systems were releasing heat from the subsurface into the ocean base, it could explain the observed thermal increase. Unlike surface volcanoes, these geothermal hotspots don't necessarily trigger visible eruptions. Rather, they emit heat steadily over thousands of years, slowly melting ice from below and altering local ocean dynamics. In this context, the Weddell Sea thermal anomaly could be the visible sign of hidden geothermal activity, fueled by a combination of Earth's internal heat and tectonic processes. This possibility gains traction considering that the Antarctic continent rests atop a system of fragmented plates, and that the ice cap's base is in direct contact with the crust in several zones not insulated by sediment layers. Another important factor is the underwater topography. The seafloor of the Weddell Sea is neither flat nor uniform. It is crisscrossed by deep canyons, submerged ridges, and irregular platforms that can channel warm water flow and redistribute heat in unpredictable patterns. Recent missions with autonomous vehicles have detected localized upward currents, as if invisible thermal plumes were seeping from the ocean's depths, similar to hydrothermal vents found elsewhere in the world. Most concerning is that these warm zones lie directly beneath some of Antarctica's most critical ice shelves, like the Filchneron and parts of the Larsen Shelf. If heat continues to weaken the base of these structures, it could accelerate their collapse, releasing enormous volumes of ice into the ocean. This would not only cause a global rise in sea levels, but would also disrupt the thermohaline circulation pattern that regulates the planet's climate. Beyond the geological and climatic implications, the thermal anomaly has sparked questions about possible extremophile life forms. Beneath the ice, in conditions of absolute darkness and sub-zero temperatures, ecosystems fueled by geothermal energy, similar to those around mid-ocean ridge hydrothermal vents, could exist. Until recently, these zones were inaccessible to conventional equipment, but new probes and drills capable of exploring without contaminating the natural balance are being developed. In 2020, a team of British scientists successfully drilled more than 1,000 meters through the ice in the Weddell Sea and deployed a probe equipped with cameras and thermal sensors. What they found was even more intriguing. Soft sediments, warmer than expected temperatures, and the presence of active microbes, confirming that in these remote depths, a biologically active world exists, sustained by energy sources that remain partially unidentified. This discovery led to the proposal that the Weddell Sea thermal anomaly might be part of a larger system of hidden hot zones beneath the Antarctic ice cap, zones not yet mapped or understood. In this scenario, the white continent would not be a passive block of ice but a dynamic, living mass, with internal processes constantly interacting with the ocean. From a technical standpoint, exploring these zones represents one of modern science's greatest challenges. Ice shelves act as formidable physical barriers, and any attempt to drill through them carries logistical risks, high costs, and the need for extreme caution to avoid disturbing fragile ecosystems. However, with the development of new autonomous robotic systems, clean drilling technologies, and long-range sensor networks, the mystery is becoming increasingly accessible. Meanwhile, the thermal anomaly persists, a warm stain on a map of freezing temperatures, reminding us that even in Earth's most inhospitable places, active forces, hidden processes, and transition zones where water, rock, and heat coexist in a fragile and silent balance, still operate. Is this anomaly an indication of deep climate changes? A hint that Earth's climate system could be altered from below, without direct human intervention? Or simply one of many geological mechanisms we have yet to fully understand? Whatever the answer may be, one thing is clear. Beneath the Antarctic ice, there is more than just cold. The hidden mountain ranges beneath the Tasman Sea, a sunken continent, between Australia and Antarctica, in a remote and rarely traveled stretch of the Southern Ocean known as the Tasman Sea, lies a series of submerged elevations that until recently remained almost completely unexplored. Thanks to recent high-resolution sonar mapping campaigns, scientists have discovered a network of underwater mountain ranges, plateaus, isolated peaks, and elevated plains that form a complex topography, more reminiscent of a lost continent's relief than of a typical ocean floor. This discovery has reignited one of the boldest geological hypotheses of recent decades: the existence of Zealandia, a continent almost entirely submerged beneath the sea. The first clues about this hidden continental mass emerged in the 1990s, when geologists began noticing that the area between New Zealand, New Caledonia, and parts of the Tasman Sea had a geological structure distinct from normal oceanic crust. Instead of thin, young oceanic crust typical of marine basins, this region showed thicker, continental-type crust with a composition similar to that of landmasses like Australia or Asia. For decades, it was debated whether this was simply a scattering of fragments from ancient supercontinents, or if it truly constituted a continuous continental platform. Everything changed in 2017, when an international group of scientists published a study that, based on seismic, bathymetric, and geological data, officially proposed the existence of an eighth continent, which they named Zealandia. According to their research, Zealandia would cover an area of about 4.9 million square kilometers, larger than India, although only about 6 to 7% of its mass is currently above sea level, forming islands such as New Zealand and New Caledonia. One of the most enigmatic sectors of Zealandia lies precisely beneath the Tasman Sea, between Australia's southeastern coast and the Campbell Plateau. In this region, sonar maps have revealed submarine mountain ranges rising up to 3,000 meters above the surrounding seabed, some with sharply defined peaks, marked valleys, and structures that, on dry land, would resemble mountain chains like the Alps or the Andes. What is most striking is not just their size, but the apparent organization of these structures into patterns that resemble the tectonic arrangement of emerged mountain ranges. Unlike mid-ocean ridges formed by seafloor spreading, these submerged chains show folding, faulting, and signs of continental collision, suggesting that at some point in geological history they stood above sea level or at least formed exposed coastal regions. Rock samples extracted through deep drilling have revealed granite formations, continental sediments, and even fragments of metamorphic rocks, typical of high-pressure, high-temperature environments. All this points to a complex past, a history of collision, separation, submersion, and transformation that unfolded over hundreds of millions of years, parallel to the breakup of the supercontinent Gondwana. The most widely accepted theory holds that Zealandia separated from Australia between 80 and 100 million years ago during the fragmentation of Gondwana and then underwent a slow process of thinning and sinking, probably driven by the subduction of the Pacific Plate beneath the Indo-Australian Plate. In this process, vast regions of continental mass would have submerged, leaving only the highest parts exposed as archipelagos. Yet some elements don't fully align. For instance, certain structures found in the Tasman Sea seem too young to be relics of Gondwana, leading to speculation that more recent volcanic or uplift processes may have reshaped parts of the submerged terrain. In certain sectors, evidence of hydrothermal activity has been found, along with basaltic formations indicating post-submersion magmatic emissions. Another, more speculative hypothesis suggests that some of these submarine mountain ranges may have been partially exposed as recently as 15,000 to 20,000 years ago, during the last glacial maximum, when sea levels were 120 to 130 meters lower than today. If this were true, parts of the present Tasman seafloor could have been islands, exposed banks, or even habitable platforms. This possibility has sparked the interest of marine archaeologists, now searching for signs of human activity on the submerged platforms of the South Pacific. So far, no confirmed ruins or artifacts have been found, but the logistical challenges of excavating or precisely mapping the seabed at such depths are enormous, and exploration has only just begun. However, conditions for life would have existed: temperate climates, fertile volcanic soils, and abundant marine resources. The coasts of Zealandia, when exposed, could have been among the most attractive regions of the prehistoric southern hemisphere. Questions have also arisen about the current biodiversity of the region. The mountainous submarine environments of the Tasman Sea harbor unique ecosystems, with invertebrate species found nowhere else on Earth. Many of these organisms live in deep canyons, caves, and steep slopes, exhibiting extraordinary adaptations to pressure and darkness. Some marine biologists believe these species could have evolved in isolation for millions of years, making Zealandia a submerged biodiversity reservoir of incalculable value, comparable to the Galapagos Islands, but hidden beneath the waves. From a legal and geopolitical perspective, recognizing Zealandia as a continent has sparked debate as well. Who owns this submerged territory? Should it be included in the exclusive economic zones of the countries whose coasts emerge from it? Could its mineral or biological resources be exploited? International maritime law offers no clear answers for invisible continental territories. What is indisputable is that the Tasman Sea conceals beneath its waters much more than simple geological formations. What appears from the surface as a uniform blue expanse is, In reality, a region filled with mountains, plateaus, valleys, and structures that once were part of Earth's living surface. It is as if the ocean had swallowed an entire continent, leaving only submerged clues for future explorers to uncover. As missions using submersible robots, manned vehicles, and advanced mapping technology continue, the profile of these hidden mountain ranges is becoming sharper. And with each new expedition, it becomes clearer that our understanding of Earth's geological history remains incomplete. The mountain ranges of the Tasman Sea are not mere accidents of terrain. They are the ghostly peaks of a sunken continent, patiently awaiting their story to be fully told. The expanding dead zones of the Indian Ocean areas without oxygen. At first glance, the Indian Ocean appears to be a tranquil body of water, bordered by densely populated coastlines and crossed by vital commercial routes. Yet beneath its surface lies an alarming phenomenon that has been growing silently for decades. The accelerated expansion of dead zones, vast regions where dissolved oxygen levels are so low that marine life cannot be sustained. Even more unsettling, unlike in other oceans, the dead zones of the Indian Ocean are the largest and most persistent on the planet, and they continue to grow, with the full scope and consequences of this silent phenomenon still not fully understood. Oceanic dead zones are not a new concept. Known since the mid-20th century, they are typically associated with coastal areas where excess nutrients, mainly from human activities like intensive agriculture and wastewater discharge, provoke massive algal blooms. When these algae die, their decomposition consumes the oxygen dissolved in the water, creating hypoxic, low oxygen, or anoxic, zero oxygen, conditions that suffocate fish, mollusks, and other organisms. The Gulf of Mexico and the Baltic Sea, for example, are emblematic in the study of this kind of environmental degradation. However, what is happening in the Indian Ocean is different in both scale and dynamics. Instead of being confined to coastal areas, dead zones here stretch across hundreds of thousands of square kilometers in open waters, particularly in the Arabian Sea and the Gulf of Oman. These regions feature layers of anoxic water reaching depths of up to 1,000 meters, and they do so permanently or semi-permanently, without natural oxygen replenishment for years. One of the most striking discoveries occurred in 2016, when an international expedition led by the UK's National Oceanography Centre deployed a fleet of autonomous underwater vehicles, gliders, in the Gulf of Oman. The sensors revealed an alarming truth. The anoxic area was more than twice as large as previously estimated, covering a surface area bigger than the United Kingdom. Even more disturbing, oxygen levels in these waters were near zero, even at depths where some vertical mixing was expected. This triggered a series of new investigations that began to focus on an increasingly clear reality. The Indian Ocean is losing oxygen faster than any other ocean in the world. Since the 1960s, its total oxygen content has steadily declined, and the oxygen-deprived layers have expanded in both depth and area. Scientists have begun referring to this region as a mega-dead zone, with unique features that make it especially difficult to reverse. The causes of this phenomenon are multiple and interwoven into a complex system. One of the main drivers is global warming. As surface ocean temperatures rise, the upper layers become warmer and less dense, reducing vertical mixing with deeper waters. This prevents atmospheric oxygen from diffusing into the lower layers, trapping entire volumes of water in isolation. This effect, known as thermal stratification, has been particularly intense in the Indian Ocean due to sustained warming over recent decades. Another crucial factor is regional ocean circulation. Unlike the Atlantic or Pacific Oceans, the Indian Ocean has no direct connection to polar regions in its northern part, meaning it does not regularly receive infusions of cold, oxygen-rich water from the poles. Its circulation is more closed and largely depends on seasonal monsoon currents, which, due to an increasingly erratic climate, have weakened and become less reliable. This further contributes to the stagnation of deep waters. Human activity on land plays a major role as well. The region surrounding the Indian Ocean, including India, Pakistan, Iran, and parts of the Horn of Africa, has experienced explosive population and agricultural growth over the past decades. Fertilizer runoff, organic waste, and industrial pollutants enter the ocean via rivers like the Indus, the Ganges, and the Tigris, fueling massive eutrophication even far from the coast, carried by surface currents. Perhaps the most disturbing aspect of these dead zones is their impact on marine life and global ecosystems. In these regions, fish simply cannot survive. Populations migrate, diminish, or collapse entirely. Mollusks and crustaceans, unable to move fast enough, die en masse. In their place, anaerobic microorganisms thrive, some of which produce toxic compounds such as hydrogen sulfide, the same deadly gas found in volcanic emissions. These microbial communities completely change the food chain, making it simpler, more fragile, and less productive. The collapse of biodiversity not only threatens local species, it also affects millions of people who depend on fishing in these waters. Countries like Yemen, Oman, Somalia, and even parts of southern India are witnessing the displacement, reduction, or disappearance of fish stocks. For coastal communities that rely almost exclusively on the sea for survival, dead zones are not just an ecological problem. They are a direct threat to food security and economic stability. Moreover, the process creates a feedback loop. Anoxic waters prevent the complete decomposition of organic material, which can lead to the accumulation of methane and other greenhouse gases on the seafloor. If these gas pockets are released on a large scale, they could further accelerate global warming, creating a vicious cycle that would be hard to stop. Despite the magnitude of the problem, the Indian Ocean's dead zones have not received as much media or political attention as other aspects of climate change. Their remote location, scientific complexity, and lack of constant monitoring have kept much of the phenomenon off the radar. But scientists warn that the issue is growing silently, and that in the future, these zones could merge, expand, and even reach into other ocean basins if urgent action is not taken. What can be done? The solution is far from simple. It requires a combination of international policies that include global emission reductions, sustainable nutrient management in agriculture, the protection of mangroves and wetlands that act as natural filters, and the development of real-time marine monitoring systems. Researchers are also investigating the use of autonomous robots and ocean monitoring satellites to track the expansion of dead zones in near real time, with the hope of anticipating impacts and reacting before it's too late. From a scientific perspective, the dead zones of the Indian Ocean are a natural laboratory, allowing researchers to study how oceans respond to climate change, pollution, and circulation disruptions. But they are also a warning. The sea, vast as it is not immune to human damage. What once seemed like an infinite reservoir of life and renewal can transform into a liquid desert, silent from the surface but deadly in its depths. Meanwhile, the Indian Ocean keeps its silence. Beneath its warm waters, life retreats, displaced by a chemical void where breath is no longer possible. And it does so slowly, without explosions, without visible catastrophes. Only through absence, the most unsettling of all signals. Thank you for joining me on this journey through the mysteries hidden deep within the ocean. Stories that may not have clear answers, but undoubtedly invite us to imagine. Until next time, rest well.